There we go. Says I'm live. Okay. Are we live? Although I've got this thing here. I've got another window somewhere around here. There we go. Live? Yeah, looks like we're live. Okay. Hello out there. There's the chat. Okay.
Nice. Okay. Works.
We are here. I don't know if anybody's watching at this point. I guess it'll tell us, right? 3 watching now. Okay, everybody out there. Well, let's get our camera set up a little bit so we can see everybody. Okay, bem-vindos todos. Welcome to the first meetup of Portugal programming languages. Now, if my Portuguese was much better, I could try to do all this in Portuguese, but it seems like the programming world wants to be English, even in Portugal, right? So, oh, there we go. I can see the delay. All right. So this is the kickoff of this meetup that's been started, and this first meeting is going to be about array programming languages, which is something that I personally have gotten into over the last year or two. And just as a note, I don't want to do this as like a monologue or presentation, a bunch of people here, and people online. Ideally, let's just have this as a conversation. I'm going to just try to walk you through everything that I've discovered and kind of organized in terms of introducing the ideas of array programming languages. But to start out, I'll introduce myself. My name is Christopher Augustus. And my first programming language ever was actually APL, one of the array programming languages, only when I was a kid, and I didn't do it for very long. My most recent programming language that's new is K. I'm starting to dabble in a little bit. Over most of my programming has been in C++, however. I'd say I've written more lines of code in that than anything else. Recently, mostly when I want to get paid, I tend to do Kotlin and Swift, a lot of mobile. And my favorite languages at the moment, if I could program in, and it doesn't matter what the solution is or whether it's the perfect solution, just what I enjoy writing code in, I'd say my top 3 right now are BQN, which is one of the array languages, Scheme, which is a list, and I'm really enjoying Erlang so far as I'm diving into it. So that's it for my introductions. Go ahead and introduce yourself. Say whatever you want about yourself, languages you like, you work in, anything. The floor is open.
Okay, so I'm Justin, and I've dabbled in array languages before. I sort of looked at J mostly, tried it out. Never really got that deep into it. And then historically, I've done a couple of things. I've done Java, Python, JavaScript, and a bit of Rust, sort of substantially. I have some terrible Haskell code sitting on a server that I use on a daily basis and no longer know how to deploy, which is fun. And then, played around with a couple other things, Raku, Prolog. I've spent a lot of time wanting to learn Prolog and just keep bouncing off of it.
Really?
Yeah, it's a tangent, but I find it really appealing, but also really frustrating. Yeah.
Erlang, I guess its syntax was based on Prolog, although I've never done Prolog.
Yeah. Yeah, I think the Erlang syntax, I've seen that, but and Prolog's a really cool idea. I just don't think. I think it makes certain compromises that don't work out.
Okay.
I don't know, and maybe I just never got over the hump.
Well, maybe at some point we'll dive into. I mean, I'm sure as part of the Progling base and the Progling Cast project, I'll be exploring the what is the category? Logic programming. if you put it into a paradigm. So, do you have favorites? Like, regardless of solution, you just enjoy writing code in language?
No. Honestly, I haven't. Rust appeals to me in a lot of ways, but also really frustrates me. And again, I'm not sure if so. Of the four languages that I've written a fair bit of code in, I've written the least in Rust, and so maybe I need to get over the hurdle. Like, this is going to be really disappointing, but I reach for Java to do things in. Yeah.
There's no wrong answer. I mean,
No, sure.
It's a matter of preference. And
It's
you,
just-
you seem very polyglottal. You know a lot of languages, and you've worked
Yeah.
in a lot of languages across the spectrum. So Array, Haskell, that's functional programming.
Yeah.
Prolog is logic programming. Yeah.
Raku is just
Perl 6,
chaos. Yes.
Yeah. Okay. I know nothing of Perl. Steve knows a lot of Perl, but I never touched it. All right. Good to hear. So next.
Yeah, so I'm Jerry, and I started programming as like university courses. So I started with C, then I took Java, then PHP, and then Python. So Python was the result that was my favorite language for long, and it's the one I'm most experienced with. But then I took optional course of Haskell, and
Wow.
it was very nice because it showed me ways that people say that Python is functional, and when you do Haskell, you know that Python is not functional in like so many
Who
ways.
says Python's functional?
Like a lot of people are like, you're like that you should do it. That you shouldn't write Python like Java. No, yeah, but it can. That's
It
yeah.
can do it.
Like the people who do Python say that it can, but people who do Haskell knows what they know. So yeah. So I took Haskell, and then I wanted to learn Rust because there is the guy on YouTube called the Primogen.
Oh yeah.
And he's like very, it's hard not to watch him. So I was like, okay,
It's hard not to watch him.
thanks to him I learned Vim and I learned Rust. So I think that he's very
Neil Vim, right?
yeah, of course,
Yeah.
and he's very influential. And the same way I followed the code report for long.
Oh,
And
Connor's
since
site,
Connor
okay, yeah.
went to array languages, that's why I'm here, because I
Great.
started listening to Arraycast and I heard most of it. Yeah. So I already tried J for maybe
Really?
2 hours or something.
Okay.
But I tried to try APL and the PQN pad both for like an hour or something.
So the REPLs.
Yeah,
So
the-
you're
yeah,
on
the-
J
the-
Playground and.
Yeah, the
trying
J
to-
I had installed on my machine, but
Oh, okay.
the APL and PQN I tried only
Yeah.
on the browser. And the like first reason why I'm here is that if it can improve my NumPy, that will be
okay.
worthy here. And if I learn new paradigm the way Haskell opened my mind, that
Yeah.
it will be even better.
Well, I think you have a fan of Python in Connor for sure, and he talks about NumPy. And if you listen to some of the Arraycast, if you heard that podcast, he often will. In fact, recently I was listening to the episodes where they talk about what qualifies as an array language and what doesn't. So like what's in the circle, what's out of the circle, how do these circles overlap? So by the way, we're looking at this diagram. This is Connor's diagram, Connor Hoekstra. I would say I stole it, but I actually asked permission to use it. He said okay. So I've borrowed it. Why make my own diagram when he has such a wonderful one here? So this is one that he's built up, and if you listen back to some of the past episodes of the Arraycast, it went from a Microsoft Paint with the quick dirty things, and then they're arguing about it, and then finally arrives at this. But as we can see, we've got this category. The red circle is what I guess currently the consensus amongst that group is these are the officially array languages. The smaller circle, the green, is the subset of Iversonian languages. Ken Iverson being the creator of APL, and kind of I think he's just seen as the great granddaddy of array languages, right? In that sense, especially his original document, which I'll show in a minute. And so there's another episode where they talk about what's in the green circle, what's not in the green circle. Then of course combinators, which overlaps with arrays, and because Connor's a big fan of it, I've become a big fan of it. I know it sounds, I think I've kind of personally become like a what do they call that, tribute band? I'm like the Rockstar Code Report tribute band. But combinators, there's some overlap there, and there's languages where combinators that exist that are not array languages. We see Haskell, right? So both of you've done code in Haskell, and you said was it in production or just stuff for yourself?
Personal. I mean, it's software I use on a daily basis.
Well, it's production.
But it's
Production
it
of
doesn't.
one.
Yeah, it doesn't have users other than me.
Other than
right?
you, user of one, yeah. And then you took a class in Haskell.
Yeah, I took now I work in Rust, and
Okay.
I write Rust very like Haskell. That I write,
Yeah.
a lot of you cannot do in Rust some things you can do in Haskell, but still it's like good enough, and the language is perfect. So
It has some influence from Haskell. I'd say more probably from OCaml, but those are
Yeah.
both ML family languages. So yeah, and because I think you can get fairly functional in Rust to a degree. But yeah, and so Rust isn't even on the chart here. And then we see, I guess the little wolf is that's.
Yeah, I was gonna
Wolf.
say there's like 3 or 4 that I don't know.
Well, some of these aren't. Well, yeah, like
Like that they don't
NumPy.
recognize.
NumPy is a library, right?
Right.
Technically, it's not its own language. So, but he's included it on there. Julia is definitely a language. MATLAB is a language. Fortran is. I think it predates Lisp. Lisp is like 1958. Fortran's like 1957. So it goes all the way back there. But he's got it there as an array language. R. I have no experience in that. C with the lambda there. I think this is, not sure, but I think that C with the lambda is a single assignment C. I've heard Connor talk about it. Dex is a fairly obscure one that's out there. Remora, I don't know. KX is the KX languages. Neal, APL, of course. The dialog logo is the dialog specific APL. J, BQ.
The V in there or the.
This little Q
Oh
with
yes,
the D.
the half D.
Yeah, and only recently did they agree on what the official APL logo should be with the apple. And so before that, if you look at some of the code report videos, he's using mostly the dialog logo to just represent APL in general. We've got Weewan here in the center. And then off here, there's Clojure. You guys have any experience in Clojure at all? You mentioned Java. Clojure runs on the JVM.
I've tried to get something working in Clojure once, but
Yeah, I'm not sure what the other one is.
Minuscule influence.
All right, I'm going to open up the rest of the tabs here that I've got under just the category of array. So I've got a bunch of tabs. What's interesting is on the live view, when I open the browser tabs, you guys can't see the browser tabs. So we can see them here, but I'm going to, you can't see the drop-down menu.
So sorry, what was the little fox and the thing that looks like a
Actually, I'm not doing it here. I'm doing
//
it.
flame?
This is Wolfram, right?
Oh, okay, yeah.
Oh no, I'm sorry. Isn't it Mathematica from Wolfram?
Yes.
Yeah, this is Mathematica. So what's interesting is that there's a mix on here of languages that are freely available and open source, and languages that are very proprietary and you have to pay to use them, right? So I believe Mathematica and MATLAB are both pay the price. Dialog, that's the case, although there is a free version, and I've been corrected by Adam. It's not a trial. It is a full version of Dialog for non-commercial and educational use. And you can download that, and I've downloaded that, and I have that. J is open source. Sorry, go ahead.
in this way, the MATLAB is also for educational purposes free, I believe.
They have a free version. I don't know about Mathematica, maybe. Haskell's certainly open source. Clojure is. Fortran, I don't even know of any Fortran implementations. Julia is open source. R, probably, I think so. K, go ahead.
Sorry, there might be a GNU Fortran, I think.
Probably,
Yeah.
yeah. That's what I was about to say. I've never even used it, and I don't go back far enough to actually have programmed in it, although technically APL goes back pretty far.
But there is the open source MATLAB. I don't know how is it called.
There is.
Not like the MATLAB, but it has different name. But on like Linux Word is the MATLAB.
They give it a different name. Yeah. Then what else do we have on here? So Neal, they've had an Arraycast episode where they talk about a Neal, but there's also this is important. I'll bring it up, show a link. But there's a good Discord server called the APL Farm. I don't know. Have you guys seen that one? Okay, at some point I'll bring that up and show it to you. But all the array, it's the community of array programming people, and they have it also on Matrix. In fact, I think Marshall and Zyma are on Matrix, but they mirror echo their chats back into Discord. But the main channels that they actually have in there under the APL farm is APL, J, BQN, K, and WeWa. And they had a channel for Nial, but I think it didn't have much activity, so they deprecated that. Let me go ahead and let's open this. Whoops, cancel. I put the wrong one. Let's see, abrir todos. Yes. And this should show up on the live stream. So I just want to do this. We've already got that picture. Okay, so this is just this is the GitHub repo that Connor provides. He's got a GitHub account. This is where the diagram is. But there's a lot more of that in here. There's actually a breakdown of the languages. You can see he makes some categories here, and we can see how he's kind of ranked the things that he shows in the diagram here. There's dialogue. CAP, by the way, I forgot to include some stuff on CAP. And I don't know if you know, but he started a new podcast called Tacit Talk. Have you seen that?
No, not yet. But
that's a whole other can of worms that we may or may not have time to get into, going fully tacit. But his first few he just had it last night, was the creator of CAP. So CAP is an array programming language very close to APL on Kotlin. And then, of course, J, which you said you installed. You've done some coding in J. I've got a little more experience with that, doing the Bye Bye Hello World for J. BQN, WeWa, Q, which is, we'll get into that. And there's Julia, MATLAB, NumPy, R, Nial, Futhark. Maybe one of those on there on the diagram is Futhark. Maybe it's this one. I'm not sure what the logo is. Right, so Futhark is optimized for the GPU. And actually in the podcast where they're talking about it, there's some debate back and forth of whether it truly qualifies as an array language or an Iversonian language. There's Dex, I think is something out of Google research. Ivy is the calculator made by the guy at Google who created Go. What was his name? I forget. They talked about him on there. Rob Pike. There it is. There's his name right there, Rob Pike. SAC, I don't know, Array Fire. These are libraries, and that's what I think you can see he's categorized them. So main, fringe, interesting. He's got CAP as fringe. So APL family, non-APL family, research array languages. So Nial, Futhark, Dex, Ivy, SAC, and then these are the libraries, including. Is NumPy on there? Do we not see it?
The NumPy is in the blue at the top.
It's in the blue. Oh, he's treating it as a language, though. Oh, yeah. He's got a thing that says library, not an actual language. Okay. Have either one of you guys used NumPy at all?
Yeah, like I use it a lot. Like basically when I do Python, I do NumPy.
And you were saying one of the reasons you wanted to understand the array languages better was so you could make more use of that.
No, I'm like, because I took a lot from Haskell and it changed the way I write Python. Before I learned Rust, it changed the way I write Python again. So, but if I learn some array languages and the only benefit will be that I will write better NumPy, that's worth it, as is. And if I learn more, even better. Because I think you cannot right now do the stuff with the BQN that you can do with NumPy. With the ecosystem and stuff.
You can't do or can do?
It will be I don't know. I spent with BQN 10 minutes, but I believe that the things you can do in NumPy is like this, that you have the whole Python ecosystem and stuff,
all
the I/O and everything.
You're saying about everything else that's not necessarily manipulation of data arrays.
Yeah.
But everything else you want to do is
yes.
there. Yeah.
So.
Yeah.
Sort of an interesting thing about the first chart is you've got a bunch of things that I consider general purpose languages, and then you've got some borderline things I don't know what all you can do in MATLAB, maybe, but I definitely
imagine that if you're going to write a website, you're more likely to write it in Haskell or Clojure than in MATLAB or Mathematica. I'm sure somebody has at some point hosted their website on Mathematica, and that's probably a horrible, wonderfully cursed project, but you don't think about doing it. So to your point, one of the things with something like NumPy is that, yeah, you're in an ecosystem that has all these things that are general purpose tools.
Yeah, that is definitely the selling point of Python in general, right? Is the vast reservoir of tools and libraries and things that are just already written that you can bring in and use.
Hillel Wayne says the thing that keeps him on Python, and he's played with literary languages and stuff, he says the thing that keeps him using Python is that for any problem, it's at least the fourth best language. For
The fourth best language. It's definitely, there's a mixture of what I would say are, more generalized, broadly applicable languages, and then very tailored, specific solution oriented. Although, a lot of them make an effort to try to adapt to supporting things like web programming. For example, APL, Adam has said a couple of times that, they have a website there, somebody will create a library and that sort of thing. It's definitely not, in terms of the core primitives of the language, the diamond of primitives that kind of work together. Doing web programming is not part of that, right? You're going out to the edge, to the fringe, getting some other library, figuring out some way to do a web service or something like that with it in that case.
A lot of tools, like they fork. Either you use them and you play with them for a little while and you abandon them, or they start to take over and start to expand what they do. You just think,
Right.
let me add one more thing to it.
Yeah.
Let me start doing this task in that and all, and then you're doing web programming in APL.
Well, we see
how it
that
goes.
we see that going both directions,
Right.
right? JavaScript, only as a scripting language within a web browser, extended its reach into the back end, right? That was the famous thing with Node.js. It's a good point. It's a really good point. So I got a bunch of tabs here. We don't necessarily have to go through everything. I just want to make sure I touch on, if I'm saying enough here. Oh, so this was a thing. So I'm trying to learn Portuguese. I'm working to become a citizen here, so I'm going to have to actually speak fluently. I'm a resident, and I've been living here for a while. So all my computer stuff is in the Portuguese language, all the menus and all that sort of stuff. And I'm trying to write as much in the language as I can. And looking at array programming, of course, we go to Wikipedia, we see array programming. It's a category, it's known to Wikipedia, we got people talking about it. This is their definition of it. Probably some of this was written up by people in the array community to describe what it is, right? But if we go to the Portugal Wikipedia, now Portuguese, of course, on Wikipedia is mostly Brazilian, right? They don't actually distinguish European Portuguese. As for those of us who live here, we're in the minority of that community. So they had the definition aranjo for array, right? But there is no equivalent for array programming. There is nothing in Portuguese here for that word itself. And when I look at paradigms in Portuguese, paradigma de programação, if we go down to the end, the closest thing we can find is programação vectoral. So vector programming, I'm assuming. And notice that it's in red. Somebody didn't even make a page, right? It's like there's no page there. It's a definition.
I think it's waiting for you to rewrite it for like array programming and
Make a
points to that previous site.
So I'm going to assume our best Portuguese speaker here is Jerry. So this is a challenge for somebody to think about. I was thinking, what should the word in Portuguese be? Should it be programação de arranjos, programming of arrays, or should it be programação com arranjos?
I'm extremely flattered. I'm from Czech Republic, so
Are you from Czech
I have
Republic?
like exactly zero knowledge. That is not true. I learned 5 words in Portuguese, so
Okay.
I have 5 words with tragically bad pronunciation, and that's my Portuguese.
Okay. So we're all not native speakers. My mistake. We're all not native speakers of
I'm
Portuguese.
Yeah.
So anybody out there who speaks Portuguese, the vote is it's either going to be, because there is no word for like, I can't figure out there's a word for being array-like, right? There's the word array, but like vectorial is vector-like. Arranjal. Okay, so we'll move on.
Tried ChatGPT for these tasks.
Well, it's just
Wonderful.
going to use the same resources we're using. It's just sucked up the web, and it's going to give us the same answers. But no, you
Yeah.
can try ChatGPT and see what it has to say.
No, because like when there's word, I know the word or I heard it a few times, but I cannot,
Yeah.
it didn't come to my mind. I just type it there, and it's like, you searching for this word? And I was like, yes, I do, and I can do it for an hour, or I can have it in 2 minutes,
Well, maybe I'll start an online poll and try to get people to vote for what the proper term should be. And then once we have a term, maybe I'll go out and make a Wikipedia page equivalent in Portuguese. It'll be an exercise for me to try to translate. But anyway, we'll move on from that. There's nobody here who wants to talk about that. So this is the original essay. As we've seen, notation as a tool of thought. I should probably crank up the font size on that, right? So we can see it better and people online can see it better. Have you guys seen this or checked out this document? It's pretty good. This is actually hosted on the JSoftware site. Well, so that's convenient, the little things, but we don't really need to go into that. Then this is the APL Wiki, a great resource. You guys familiar with this one? So, if people haven't seen it, this is a great resource. I think Adam was the admin at one point. He was asking if somebody wanted to take over for him because it was a lot of work. But it covers pretty much everything you want to know about APL and also addresses the other array languages as well. So it's a great resource. This is the combinatory logic page of Connor Hoekstra. So he's got his code report, but he's also got this. And I don't know if you guys are into this stuff at all, the combinatories. Maybe we'll talk about that a little bit at the end, or you just let me know if you want to talk about it more. But he's got a YouTube video on here. He's been going around giving this presentation at various conferences, usually like functional programming conferences, talking about composition, intuition, and he shows people in the various languages, Rust, C++, etc., Python. But you'll see he'll quickly drive right into, here's how we do it in APL and BQN and WeWa, and this is why it's so much cooler and so much shorter and so much simpler. So of course there's the Code Report YouTube channel. This is his tacit talk. This is his interview last night with creator of CAP. And I don't know if we need to play, this is the Proglang base site where Proglang Cast is hosted, the videos we've done so far, including our live coverage of this. But there was another, there it is right there. So this is a year ago, and actually do we have any sound here? Let's see. The Proglang base site where Proglang Cast is hosted, the videos we've done so far. Live. Let's mute that. Let's see if we get sound on this. Have you guys seen this particular video?
I did.
I have not.
You've not seen it? Okay, this is a really cool one. This one is a year ago, and it's one of his more recent ones where he compares a single algorithm in all the different programming languages. And not all of them, but 24 different ones. So you can see we've got Ruby, Racket, Erlang, Swift, D, Scala, JavaScript, Python, BQN, Clojure, APL, Java, Go, J, Dart, TypeScript, C++, Elixir, Kotlin, Haskell, C#, PHP, C, and Rust.
Good job.
Got them all. So he goes through these one by one. And it's a leak code problem. I'm not going to play the whole video, but you'll see he'll go through describe the problem. And he's going to show there's the code in C, there's Go, there's PHP. Didn't you mention? Somebody mentioned PHP. You did. Was it something that you chose to program, or they made you program?
That was one of the courses I had to take, but it got like one positive thing, and that was I don't know how it's called in the PHP word, but like the composer, or isn't a software like this that takes care of the packages and stuff.
Oh, okay, package management.
Since I came from Java and C, I was like, oh, this is magnificent, it really works.
Oh, okay, great.
So then in Python you have pip and you have cargo and
Right.
Rust and stuff. So it's not like that you don't have it elsewhere, but I
Yeah.
think PHP might have been one of the first to have like a decent package manager.
I think it was PHP or Perl.
Maybe
Steve would know better.
I don't know.
He knows PHP and he knows Perl. I don't know either, but there was one of those which was credited as the creation of package management. Do you
I
remember
think
what
it
it
was
was?
CPAN probably. with
CPAN
Perl.
from Perl. That's right.
Yeah. I
Yeah.
think back in like 2000, CPAN was already a thing and you could pull stuff down.
Right.
But no one had figured out that installing things globally on your system was a bad idea. So
Yeah.
when you installed something from CPAN, it was just like, that's your version of the library. So
Right.
the idea that you have two projects that have different versions and they need to coexist was, I believe, not something anybody tried to solve. And that was a mess, of course. And
Baby steps.
10 years later, people started working on that.
It's a big issue in of course, the NPM node environment. It's one of the things that actually the creator of the new language that's coming up called Rock. Do you know this language, Richard Feldman?
No.
He's
He's
put
part of Elm World, right?
Yeah, he's known for, he's done books on Elm. He's been a big participant, contributor, not a creator of the language itself, but a luminary in the world of Elm. And he's got a book. And he's been working on a new language called Rock. It's not an array language. But the reason I brought that up is he's really focusing on how to deal with the whole package management, version consolidation, verification problem. He's got a pretty unique approach to that. So there's Python. He puts Dart, Swift, and Erlang all on the same page. Then we get down to JavaScript, TypeScript, there's Clojure and Racket, which are both Lisps. So there's all your favorite parentheses. And what's we got here? C#, Elixir, and Kotlin. Interesting choice of languages to put together. Scala and Ruby. I think I would have put Elixir and Ruby next to each other, right? I mean, you can see the syntax is almost identical. The main influence to Elixir is Ruby. Scala and Ruby. And I would have put Scala and Kotlin together and Clojure together because they're all three are on the JVM. D I've never used. You guys?
I think it's a C++ competitor.
Yeah, well, yeah, it's like the D. It's like the next letter in the
Yeah.
alphabet. Yeah. There's Haskell standing on its own with a pretty unique way of thinking and syntax. I'm kind of rolling through and showing the C++, not my favorite language, even though I've written more code in that than anything in my life. I feel I have the right to complain about it. I've earned that right. And Rust. So I got into Rust around 2015, and I was getting excited about it and diving into it, but I'm starting to veer away from it for various reasons. And you mentioned Primogen in his videos. He seems to be finding Zig more attractive. He's having a little bit of buyer's remorse on Rust these days for things that he wants to do.
I remember his recent video when he said that I believe this year he will focus more on Go because he said in the
he's
video
shifting
that
around.
Rust is what he already learned, so it's time to shift somewhere else.
So we get Rust, and then we get up to Rust Solution 2, but then we get into the BQN, the array language solution. So the point I want to make here, so we're looking at all the code, right? Readable, but there's a lot of code there. And then we get down to the array solutions, solutions that look like, where are they? That. So for this particular problem, those are the three complete solutions in J, APL, and BQN. Not only one line, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characters to solve the problem. But symbols. How do you guys feel about programming in symbols versus words?
Not convinced.
Don't
I
hold
don't-
back,
I
man.
don't-
Let's hear what you really think.
Sorry, I don't have any. I don't have any. I don't have any sophisticated thoughts about it. But yeah, learning J, just like it never got to the point where the mnemonics or what have you clicked, and I was able to fluently translate, what the code was doing translate from the symbols into what the code was doing. And so it was always sort of a
Look it up kind of thing.
look it up kind
Yeah.
of thing, yeah. And it wasn't so, and that's the kind of thing that maybe with just more drilling, more practice would have gotten over. And I'm not sure. The idea that you're just tacitly, sort of applying things to arrays seemed really cool, and I liked it. The syntax was a bit of a obstacle to me, which is, I don't know. It's not really a particularly. It's just my personal experience. It's not.
But you don't feel like it's a showstopper for you? Like, given enough time, you might become more comfortable with it?
I don't know.
Okay.
It's hard to tell.
Well, there's a category of people out there that will immediately reject it out of hand. That will just say, I'm not even going to try to get familiar. I don't want to have to code this way. I don't want to have to think this way. I mean, the original essay that spawned all this is notation as a tool of thought. The idea is this helps your thinking process in some way for some problems better than not using a notation like this or some kind of symbolic notation, right? Relying on words. And that is really kind of that's a strong push from the array community across the board. Now, there are some languages, for example, Q is a variation on K that uses words instead of symbols. I think almost entirely because of the idea of, in order to get people to accept programming in this style with at least an array way of thinking, right? You're manipulating arrays of data along many axes and depths. That's a challenge in and of itself. Now you add the challenge of somebody has to get familiar with symbols instead of words, and if they don't like that, they're never going to get to that first part. So here's Q, right? Looks like other languages, but it's an array-oriented language.
Are we going to get a Q version of this? I don't remember the beginning.
I haven't seen Connor actually put anything up there on Q itself. We can take a look at the language description. It's not one of the things I dove into.
It'd be interesting to see it like
Side by side, Q, APL, and J, or something like that.
Yeah, totally. Actually, he might have a video in there somewhere where he's got that.
It is interesting that looking at the three of these, you can see that they're parallel.
Yeah.
That the symbols are different, but they're. I'm guessing here, of course, because I don't know the symbols for each of these three languages, but they look pretty clearly parallel. Like each one, it's just a syntactic translation, I'm guessing.
Yeah, they're semantically equivalent. In other words, all three languages for this particular problem have exactly the same set of tools to solve the problem. And as you can see, only the symbolic notation varies. So they're exactly the same operations, the same primitives, just a different representational style. The main difference in J, of course, is that you don't need a special keyboard for that. J restricts itself to the ASCII set of symbols, as you know, that you can use on a keyboard. And I gotta admit, that's a convenience. Now, I started doing our bye-bye hello world example. I started with APL, so I needed to put in the special keys for that. I then did BQN, I needed to do the special keys for that. As soon as I got the J, I could just use the keyboard freely, right? But the difference is, we've got a couple extras. So this particular, actually I probably should use the mouse so people can see what I'm doing. So this little symbol here I know is essentially maximum, it's ceiling, right? And the APL version, it makes sense, like up is the ceiling and down with the sidebar at the bottom is floor, right?
Take a look.
Whoa.
All right, so here we are in BQN. Note
Oops,
that
I didn't
we are
like
only
that.
showing.
I didn't mean to play it. Let's back this up a little bit. But, so it's the same exact, Marshall decided to use the same symbol in BQN. He uses some of the same symbols as APL and BQN. In some cases he doesn't. There's some variation. Like you can see this is a regular forward slash, and that's a forward tick, I guess. It's a superscript forward tick he decided to use for reduce or fold in this case. But in J, in the case of the maximum, it's 2 characters. So it's a greater than sign and a dot, because you've got to be limited to the set. So in that case, instead of having a single character, you've got double characters. But there's some logic to it. Greater than, so maximum, greater than, dot. The ampersand colon, I think this is a combinator. So I think this is a top in APL. It's a way of, this is a way of being more tacit with these functions. And in fact, if you want, we could you want to just watch the little section where he describes how to solve this problem in here? Okay. Let's just do it. It's not too long. He does it in BQN, but the solutions are fairly equivalent. So
Take a look.
Watch that.
All right, so here we are in BQN. Note that we are only showing the evaluation of the last expression in our REPL here, but in order to show previous expressions, the evaluation of them, we can just add this show command, and we get the evaluation of all 3 of our test cases that we saw earlier. So right now we're just showing the input as the output, but let's start to build up our solution. So here, first thing we want to do is count the number of negatives. So if we check which of our values in
So the problem is, give it the maximum count of negative numbers in any array of numbers, right?
X, our argument, are less than 0, we get a Boolean mask, and then we can sum these up using a plus reduction, and this will give us the number of negative numbers. So 3 for both of our first 2 test cases and 0 for our last.
So does that first part of the expression make sense to you? I'll explain it. So there are 2 things going on here. First, he's gonna do an expression that's not tacit, that actually names the parameters. That X is a parameter name. So tacit programming really means getting rid of parameters, and that's why there's overlap when we're talking about 3 things: programming with arrays, programming with symbols, and then programming tacitly are kind of like 3 separate ideas that often get conflated and overlap, if that makes sense. So the braces are a direct definition. It's the same thing as a lambda, right? It's just an inline function being declared. So basically you're just making the body of a lambda function, right? Does that make sense? Like in Haskell lambdas, right? An unnamed function, anonymous function. So this just says the X parameter. In BQN, the X is equivalent to the omega in APL. It's the argument on the right. And APL and BQN on every line of an expression reads from right to left. Which is one of the things that's a little awkward, right? So whatever the number is on the right in this case, right, he's got maximum count. He's basically saying maximum count is this function. So this is a lambda, this is the name of the function saying maximum count. This is the parameter that's coming in. So this goes into the X, right? So he's saying X is greater than, X is less than 0, because it's reading from right to left. So the less than, in this case, well, greater than, 0 is greater than X. So X is less than 0. It's reading from right to left. I'm trying to figure out, let's go ahead and have him walk through it.
Last one. Then we basically want.
This is a very like NumPy. You just do the Boolean mask, so it says like if the number is negative, so for the first case you will have like 1 1 1 0 0 0, and then you just reduce it with the plus, so we got 3, and then you have all zeros, so you got 0.
Reminds me of a goofy trick in Python, which is that the Booleans are actually just numbers.
Yeah.
So you can, to test the number of true elements in a list, you can do sum on it.
But that's exactly what the array languages do all the time.
Yeah.
That's one of the things I actually really like. Both APL, BQ, and J, the Booleans are just zeros and ones, and they're not a separate, unique type. And the other thing that some people may miss, that you guys picked up
Want to
right
do
away,
the exact same thing.
and just stop me if I'm being pedantic, but like if I looked at this in any other language and I said, okay, well, if X is this entire array, how do I compare it to 0? Right? If I was doing this in any procedural language like C or C++, it'd be like, no, I'd have to loop over the elements of the array and do the comparison each time. A data element that's simply an array, and if you do a comparison to something on the other side, it implicitly is going to make it an array-like operation. You don't have to do anything else. You don't have to specify loop to do the comparison on each element of the array. Just going, look, this is an array. This is array programming. If you're going to compare the array to a scalar, I know I'm just going to compare that scalar to each scalar element of the array. It's just automatically, that's array programming. That's a fundamental part of it. You're working with the data in that way.
I think they call it like implicit broadcast or something like this.
It's definitely implicit broadcast. I don't know, maybe. But I think sometimes when they're presenting and describing this, like you can see Connor just jumped right into that. And like you're saying, you're right. What's the result of this? It's going to become this Boolean mask. In fact, that's what we see before he does the sum of it, right? You guys just said that. Yeah, there's the... So just by doing that alone, just by doing nothing but saying some data value that's an array, comparing it to 0, it's automatically going to apply that across the first axis of the array.
And that's why NumPy is so useful, because in Python you cannot compare list to scalar, but you can as soon as it's like NumPy array, you can do the same stuff.
And that's
you can do like 1 plus array, and it will be broadcasted to the whole.
Right. And NumPy is based on APL.
Yeah, it's like
that's the whole point of it.
It's like that.
But that's one of the central features in the appeal of these languages of array programming, is if you are going to be working with bodies of data that are arrays of however many axes, even a single axis, you have to do that in any other language that's not array programming. You have to put the iteration in. And that iteration, even if you're doing the same thing over and over and over again, I can imagine doing this in Ruby or doing it in C++ or doing it in Python, Kotlin, I would have to put that iteration in. And it just becomes noise after a certain amount of time because I'm doing the same thing. Here it just implicitly automatically happens. So we see that.
Sum these up using a plus reduction and
then that in BQI, that's the same as a / in J in APL, which is sometimes called fold, sometimes called reduce.
Yeah.
Right?
I think in BQN it's like a superscript because Marshall did every, how do you call these? It's not like the operation, but the modifiers.
It's a modifier, yeah.
He put all the modifiers as a superscript, so they are like immediately recognized.
Yeah, all of the monadic modifiers are this superscript, and then the dyadic modifiers are the little circles with little yellow circles. So there's consistency there, yeah. And then this is just so if we did this in Rust or we did it in Kotlin, it would be a fold operation, right? Fold R or fold L, I forget which way it folds. In this case, a sum, it doesn't matter. Folding, it's going to produce the same.
this will
result
give us
either
the
way.
number of negative numbers. So 3 for both of our first 2 test cases and 0 for our last one. Then we basically want to do the exact same thing, put this in parentheses and concatenate that with the beginning and turn this to a less than or a greater than sign. We also need an X in here.
So I just repeated the same operation, but in this case, instead of being less than, do greater than. And you're going to see after that what he's going to do is figure out a way to eliminate the redundancy to get the characters down, to really turn this into a code golf exercise. And then this is just an append, right, as he explained.
And this will basically give us the count of our negative numbers on the right and the count of our positive numbers on the left. And we can just replace this concatenation binary operation with the maximum, and then that will give us our answer, 3, 3, and 4. So this effectively is our solution here, but it's not what I showed on the previous slide. So let's refactor this to what I had shown before. So let's comment this out, and we can then compare what we have now. So the first thing we should do is make this point free. So we have basically a unary operation here, a unary
So that's a Haskell term, point free. That's the phrase they use for tacit.
operation here, and a
Which is really, really strange because they actually use a dot, right? And when you think point free, you think, well, there's a point there. It's really not point free.
Well, the
but
point is for the function composition, so it's not like the reducing of the arguments is has nothing to do with the dots. but the point-free solution has always many dots in them. So
Right.
Binary operation. So if you've watched my other videos, you'll know that this corresponds to a fork. And we can basically get rid of this by putting the identity function, do the same thing over here. And now we have it in point-free.
So the first thing he's done is he's made it tacit. And in order to make it tacit, he had to introduce a combinator. In this case, the fork combinator, which in APL is the phi combinator. So get into that later. But it's basically in order to get rid of parameters, you have to have a combinator of some kind. Something that takes a set of functions and produces another function so that you can just pass the values directly to it without having to name the parameters.
Notation, so there's no mention of our argument x here.
So now it's
The
tacit.
next thing we can do is borrow from what we had in our Haskell solution. So in Haskell, we only had one length. The equivalent of our length in BQN is this plus reduction, and we have two of them here. So we can reach for the psi combinator, what was called on in Haskell, and it's called over in BQN, and basically do the following. Get rid of the plus reduction in both expressions, and then add this to our max reduction in the middle with the psi combinator. And what this says is our two arguments on the left and right being passed to our binary operation, before we pass them to our binary operation max, pre-process them with this unary operation. So we're basically applying plus to both the return value from 0 less than x and 0 greater than x. The next thing we can do is try and factor out this 0. So note that
when you said before, there was the question whether we are familiar with symbols and we're okay to use them. And this is the moment when I think someone starts to overuse them, because in math sometimes you have problem, and when you write the formula the way the problem actually is stated, it's kind of obvious. You have some inputs, and in the end you have some outputs that you want to calculate. But sometimes clever people find shortcuts in the formula, and they're like, oh, this crosses out, this crosses out, this crosses out, and then you have a formula that has basically nothing to do with the actual problem, and you're like, yes, this is the inputs, this is the outputs, but why the fuck in the middle is this, and it does what should I do, what I need, it has no point. And this is exactly the moment when, if you can read it, you can still reverse it to the previous one, but now it has the syntax doesn't help at all. The way it's composed here doesn't help at all. And if you visualize it with the BQN, I don't know how is it called, that the BQN shows you diagrams.
Yeah.
That I don't
The
know.
combinators.
Have you seen it? There's some visualization tool that shows you which functions goes into which functions. And it's really helpful because in this case, when you have the
You're talking about these here.
Yeah,
there's similar. There's
for
similar
the actual
diagrams.
formula that you have for one line, it shows you the diagram this is combined with this, it's combined with this, it's combined with this, and this is the result.
Yeah.
And if you have this, and if you can parse it in your mind, it's nice because you actually. But when I see this code, the one on the previous slide, I have so which function is applied where and how? Because in Haskell, it's all right to left, so I can read it immediately, and it's and if there is the dollar sign or something that changes that, I'm okay, now I parse this before that. But in this case of combinators and stuff, you're wow, there are so many functions, but what is the order of applying them to what? The center of it, it's the max there, and it's the important thing. Is it obvious? I don't think so. There is so many functions on both ways before
It definitely takes time to figure that out. It definitely took me a lot of time to figure that out. And you're right. I still have to look at this and figure out how the forking is happening. Like you're saying, okay, the argument's coming in. It's being applied to this function, then it's applied to that function. The results of these two are applied to the center function, or is it the center then applied to the right, and then the left applied to the left? Yeah, it's difficult, and I think this is a wall that a lot of people run into. And to your point, an argument I'm sure Connor hears a lot, and I definitely hear it a lot, is why bother? What are you gaining by doing this? Why even bother with tacit in the first place? What do you gain by getting rid of those parameters? Like you're saying, if I see X in there, well, I know X is the data that came into the function. If it appears 3 times, I know it's going to show up in those places in 3 times. And you're saying there's some way that we can just rearrange the symbol so that I don't see it. It just kind of magically falls into place where it needs to fall in, and it's not obvious unless I understand that placement. that
My
happens.
point is that if you could do it with a diagram, like with the paper, with the pen and paper, it would be obvious. If you just have you have the max here and there is the arrow from here and arrow from, if you would write it as a graph, it would be obvious to completely novice people. They're like, oh, of course, there is something in the middle and it comes from this, it comes from that, there is some combination in between. But this notation doesn't help at all. There is you need to work a lot to see the graph.
So your issue is with the specific notation, not that notation is used, but this particular notation is not helping you
No.
visualize it.
As long as the programming world or any programming language will be linear, that you can write only on the left and on the right, nothing will help. If you go the Lisp way, it's unreadable, and if you go the left and right way, it's unreadable as well.
You want a fully 2-dimensional notation, like something like the flexibility.
I was thinking about it at home, but I cannot imagine programming in 2-dimensional things. You could have arguments from the bottom and from the top, and then you could have also the diagonal directions. And then you're like, oh, this is math, so I'll start doing the lines between them. So I will have the forward slash and backward slash, this is my input now, this is the input now, but it turns into great mess.
So I want to address the point you just made because it's a really good point. Even though we're gonna drift a little bit off of arrays for a second here, I think you guys will appreciate this. So this is a really great video. Let's go. I'm going to go ahead and add this to this window so we can see it. Everybody.
Yeah, Connor was recommending this video.
Yeah, it's called Stop Running Dead Programs by Jack Rusher. So this is, for me, recently, when I saw this video, it's been one of the most influential things in the way I'm thinking about programming now, which is why I'm so driven to do interactive programming. But to your point, he talks about text and the way you could really program in text. Have you guys seen this video?
I've seen it first 10 minutes or something.
Okay, there's a section in here that directly addresses what you just said. Let's see if I can find it in here.
I ended at the demo at the beginning.
Is it in the beginning?
It was the demo of I don't know, was the calculator was.
Yeah, he goes through the cards, he goes through batch processing. The whole point about this is interactive programming mostly, but he does address text. And he says if the text looked like this, he says our way of thinking about text is too limited, like you're saying, a single line, characters that you type on a keyboard. Here I think it's in here, because here he's talking about the visual acuity of us primates, right? Where does he get the thing on text? This is a good example. He says it's here. Let's watch this for a few seconds.
This sucks to write down as text. This is the Krebs cycle. Hopefully all of you learned this at school. If not, maybe read up on it. So if you imagine trying to explain this with paragraphs of text, you would never get anywhere. Our doctors would all fail. We would all be dead. Come on.
Sorry, let me back up. I know he's got a really good section because he talks about latex as a form of text. God, let's see if I can find it in here. Sorry, I should have didn't really anticipate this issue. Well, anyway, at some point in here, he shows a picture of text and he says, "This is what text is," and he shows latex, where you have the nice mathematical notation with, as you're saying, 2-dimensional, 3-dimensional with the picture. It's like, this is text. Why can't we do text like this? Why do we have to do it based on 80 columns and rows and lines and something that was created to satisfy the limitations of computing, at the very beginning. Anyway, I recommend people read this, but watch this and we'll see what I'm talking about.
Okay. It just increased the priority of this video a lot.
I highly recommend anybody that does programming to just, you don't have to agree with any of it, but just watch this video. It is just eye-opening. It's amazing, and it's Jack Rusher. And every time I talk about this video, I forget his name, which is terrible thing to do. But it is really great from the beginning. So yeah, Stop Writing Dead Programs by Jack Rusher. I'll definitely include that in the link. But
only to add to my point that what I said doesn't it doesn't immediately connect to the symbols, because the same problem is when you don't have the symbols, but such as Haskell, where you have the follow words and stuff.
yeah.
But when you have the symbols, it's so easy to write so much things on one line that doesn't need to be long at all. You know, like in APL, to write, let's say, 10, 15 symbols, it's a lot of logic. When you do it in Python or something like this, you will have there like 4 assignments. So it will be, you know, separated into pieces. Like first I have the Boolean mask, then I have the, reduction, and then I have something. You know, or like I have comparison, I have reduction, I have something. But here in APL or like BQN and all these languages, you can just, put it all there. It's like 10 symbols, so what? But these 10 symbols do a lot of things, exactly.
Yeah.
Like to see what's the final function of this line, it's not obvious even if you know what the symbol means,
Once it gets down to it. Do you guys think that it would be easier to get people involved in programming if we separated these issues from each other? Because what happens is there's so much enthusiasm, particularly like coming from Connor, to some part from me, because I like this whole code golf thing. Like, how can I get an algorithm down to the least amount of symbols, the least amount of characters? I have a fondness for this. Could I defend that and say there's a practical purpose to that? Other than winning a code golf contest? No, probably not. But what happens is, I think, in some of the evangelism of this way of thinking, and it doesn't necessarily need to be evangelized. I mean, the whole point here is finding value in doing this. If there's value to be found, can we get something out of it? But I was saying before, it's like 3 different things are overlapping here, and trying to drive somebody through all of them feels almost impossible. So we could talk about just do array programming with NumPy or Q, where you don't have to worry about symbols. And don't talk about, it doesn't need to be tacit. We don't have to get rid of arguments, right? That can be a whole separate conversation.
Yeah.
Right? If somebody, once they get comfortable with that, and they're like, yeah, I am interested in having more brevity in the way I write code, or I am interested in symbols and that sort of thing. But when you try to throw all of it at somebody at one time, right? All they have to do is be uncomfortable with one of those aspects, and then the baby's thrown out with the bathwater, right? I won't do symbols, so I don't want to hear about anything else. I'm not interested in tacit, so I don't want to hear about anything else. Does that make sense?
Well, this is what I fell in love with the test Haskell, right away, and it made my days much harder, because you start with, when you name all the arguments and and everything, it's much easier to write it because you write it as you think. But when you want to do it tacit, then you need to think much more. You just need to put much more work in, even as a writer. So then, as a reader, it's maybe twice that much. But if it's when it's explicit, there's names that doesn't mean anything because they're just placeholder and stuff. Passing the value. So you put there usually X, then you have X with some symbol on top, or you have XX and X underscore something. And it doesn't make any sense there. So it's reasonable to get rid of it, but it reads much easier because you know where it's applied where it's stated. When you write it tacitly, it's much more work to write it and to read it. So I think there is some balance between these.
Yeah, for me, I think some of it is just once I become more familiar with the way of thinking and the notation and all that, it feels like there's an advantage to be gained once you arrive there. But until you arrive there, it's nothing but a hassle, right? But that could be said about a lot of things, even in programming, just in general.
Well, I think you should first, say what is the advantage in the end. If you can write it tacitly, what it gives you. Because
Yeah,
when
you have-
you
you
say
have to-
when you say
you
when
have
you
to
say
just-
joy,
you
I
have to-
understand it.
You have to justify
When
it.
you say like joy, because I like it better, I'm like, yeah, I do
get
too.
that, yeah.
But anything else, I'm not sure.
Yeah. Yeah, it's the same sort of argument you have to make for anything in programming, right? It has to be justified to make it worth the effort.
So here's a dumb analogy. You know, when you're writing code, you know, in any old language with function calls, you're probably going to write. You've got your function foo. You're going to write foo paren x plus 1. You're not going to write let next value equal x plus 1, and then on the next line write foo x plus 1, right? You're totally comfortable with adding 1 and then calling a function on it in line. I mean, there might actually be some circumstance where, you know, you need to explain what x plus 1 is, like why the hell are we adding 1 plus x, because it's really unclear in context, you know, whatever. But normally you're just going to inline that right now. Why do you inline that? Anyone can read it if you put it on the line before and then call it. But your assumption is that everybody's comfortable. And once you've done that, you've saved 1 line. What's 1 line? 1 line's nothing, right? 1 line of text, it's free, it's 8 bytes, what have you, you know. It doesn't matter, it doesn't slow anyone down massively to do it, but you're just gonna do it because it's basically free once you're comfortable with it. And if you always, you know, extracted that temporary variable, or you always created that temporary variable, you're just adding a little bit of noise and a little bit of friction. And I think a lot of tacit programming is the same way. It's not massively more complicated to have the argument there. But once you're familiar with it, it is slightly better. It's just a minor thing. And then the question becomes like, you know, when are you code golfing, and when are you doing something that somebody who's got a degree of familiarity with the language will just find natural? Like my way of writing Haskell, which I'm not going to claim is right, but just what I personally got used to was like, basically I write things tacitly pretty much until I have to use the flip method or flip function.
Okay.
Once I use flip, I'm just like, no, I'm naming my variables, and we are not using flip, because I never got to the point where reading flip was natural. I can do it, but I'm always gonna have to stop and parse it out. So I just almost never use it. And so, you know, there's lots of tacit lines, and then it's just like, there's this old joke from back when CSS was becoming better supported by browsers. It's like, spend 30 minutes, then give up and use tables. Because, you know, you could do layout with tables. And
Yeah.
back in the day, there were bugs, and, you know, Internet Explorer was weird. And so the thing some people half seriously said was, spend 30 minutes trying to do it right, then give up and use tables.
Yeah.
And I think sometimes it's the same thing with a lot of programming language idioms. Is you can push the boundaries of them, and it may or may not be useful. And some of the time, I think that there's a case to be made for give up and use tables. Use that local variable, give it an alias, because tacit's gotten excessively complicated.
Yeah, it's thresholds, isn't it? Interesting. You seem like you agreed with him about the flip thing.
Absolutely, because this
Yeah.
is exactly my point. That when you listen to the Aircast, like all of the guys basically say or agree on the point that going full tacit doesn't work. No one is able to have the ability of like the parsing so well that any tacit form of any length, it will just click to them. No, some of them are like, you know, 1 level further or 2 level further, but it's still that I am comfortable with this line, but when it's like this line, I cannot parse it immediately. So I will do it manually, and I can, you know, hold the context for this, but I cannot hold context for that. So for me, this line should be rewritten from the tacit form, because it's unreadable for me. Someone else is like, this
Yeah.
long and stuff. And it's exactly the flip thing. I was comfortable at writing and reading the flip. But then I was like, I'm comfortable that I can read it. But it's just, I do like this menu thing all the time. And I'm like, okay, there is flip, so it's actually this parameter before that parameter, blah, 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 blah. And I was like, no. So I stopped using flip. And it just made my life easier because I could write it the first time. I don't need to do like, I'm writing it out, oh, this is the flip. So I rewrite it to the flip and I was like, oh, this is unreadable. I will, edit it and, remove the flip again. I was like, so I usually wrote the function 3 times. Without the flip, with the flip, and without the flip, it's exactly what you said.
I think though it's really worth as a learning exercise pushing these little boundaries and finding out where you're comfortable with.
Yeah, and that'll change over time too, right? What you're comfortable with a few months ago or a few years ago is going to be different than where you're at now. And as
So you
try
get to
different
the
things.
point when one flip is final, but 2 flips are
Maybe.
2 flips.
like 1 flip per line, that's fine, but 2, goddamn.
So flip, I think, is the same. It's the C combinator, and I think it's the same as selfie in APL and swap. And actually, in BQN, the same primitive is used for swapping because it flips arguments.
Yeah,
right?
yeah.
That's the idea.
Yeah,
So you swap the arguments. Yeah, interesting. But as you were saying that, I was thinking.
You said it's called selfie in some language?
In APL, because it looks like it's the little tilde with the eyes, and so it looks like a little funny face. We call it selfie.
Yeah.
Thresholds. So we talk about symbolic programming. To your point, you really can't program in any language without knowing some level of symbolic notation. So it's not a question of whether programmers are comfortable with symbolic notation. You have to know what braces do. You have to know what parentheses do. We assume that we all went through elementary school, so we at least know what plus, minus, equals, divide. Although it's usually it's a different symbol rather than a
The
slash.
equals changes, right? The equals
Oh yeah,
you
you still
learn
get
is
into
not the equals you will
comparison versus assignment versus really equals versus equivalent versus not equal, and all that. But the point is that in just about any kind of programming, there's some level of symbols that you're going to have to learn, become familiar with, just to be able to read and write code at all. Except now, with the advent of LLM-based programming, is this idea of we're going to open the world to people don't even have to think about symbols. They can literally just instruct in their verbal language what they want, and the computer is now going to generate whatever the syntax and symbols and code is, and it's going to do the work for you. And what's funny is this is being presented as this whole new frontier, this whole newfangled thing. But if we go back several decades, so I'm an old timer, if we go back several decades, there was a period way before LLMs and even before Prolog when there was a push, particularly from Knuth, to talk about programming in natural language, in English. They were trying to build languages at that time where you could write in a written language or a spoken language, take input from the user, strip off trailing blanks, and it would generate program code from you. They just didn't have the power of LLMs back then to do it, and so it was untenable. So now here we are, decades later, that dream of natural language-driven programming has resurfaced. It's not a new thing. It's come up from the depths where it wasn't really possible to now, because we've got massive machine learning analytical algorithms that build these neural nets that can sit there and say, probably the next correct phrase after this one is going to look like this. Right? It's a statistical model. It's not actually knowledge. It's not actually logic. We're now at this point where we're being told that the next frontier is, well, now you don't have to worry about any parentheses or braces or any of that. You can just talk to the machine and it'll program for you. What do you guys think of that? That's a whole can of worms. We don't have to get into that, but I just wanted to make the point about, at some level,
I think that
we have to be comfortable with symbols.
Like people who take it seriously will do the symbols again, because it's very deep in our nature to abbreviate things we do. Like when there is some street and has a long name, we will find a short name.
Yeah.
And when the short name is long, we will even make a short name of the short name. The human name, when someone has such as my Czech name is like Jaroslav,
Yeah.
No one ever said it. Like I heard it maybe like, I know I'm exaggerating a little bit, but I heard it like 10 times in my life because
Yeah.
it's too long that I have like 5 nicknames that are, you know, like short versions of the name, because no one will ever say like 9 characters for a name. And that's the point when you
Yeah.
when you will have like the some name of it. When the redaction, like the plus slash, it's
Yeah.
genius. I think
It is.
this part should be in every language, because
Yeah.
once you see it, you're like, oh gosh, this piece of symbolism is like really, this is piece of art, you know. When you compare it with the mathematical notation, you know, it's not about programming, but also the math on the, you know, with the pen and paper. This is just so good. You have some structure or set or whatever, and you just put the plus slash and that's it. So my point about symbolism, when you have when you write notes and stuff, you also do plus and minus and stuff. You don't say like add this to add,
Exactly,
add. No,
exactly.
or you put there commas, you put there pluses, you know. So I think we naturally tend to use symbols, but my argument is that for some things that are so common, so useful and stuff, we'll definitely use the symbols. But use the symbols for something you use once in a month, maybe the word will do, you know.
Yeah. So the conclusion I want to point out is that it's not a question of whether people are going to be comfortable with symbols. It's a question of the threshold. At what point is too many or the wrong kind or not being two-dimensional or being one-dimensional becomes a pain point. And that's the case with all of this stuff. And for me, the test is, I've now thought about this a lot lately, and I think this is what's happening to people subconsciously, whether they articulate it in their minds or not. Cognitive load. If I look at a piece of code, there's some aspect of it in which I feel like there's too much cognitive load. And that can be caused by a bunch of things. For me, it's usually caused by too much code, just too many words. I don't like intermediate variables. I don't like somebody assigning a name to some value to a variable and then immediately using that variable and that's it. It's like I can see what that value is. You're making me read the name in English of the value I already see, and then you're just assigning it in the next string. Whereas I've worked with people who are the opposite. If they don't have that, they find that's cognitive load. They're like, you've named it, you've told me what it is, you've effectively documented the code for me, and I don't really even have to read the symbols, I can just kind of read the documentation through. In fact, Steve is more on that side. I find the more I have to read words, generally, it's not always the case, but that actually increases my cognitive load. I find like, if you can get rid of the arguments, once I'm familiar, once I'm comfortable with, I can see how the tacit stuff gets applied, then I have to think less. In the beginning, I have to think more, to your point. I have to think more to understand, where is this value being plugged in? I don't quite see the tacit relationships here. But once I understand it, now I can think less. So it's like you go up the hill so that you can get to the lower point, right? It's like the local maximum kind of thing. So I don't know what you guys think about that, but it's not a question of symbols, it's only a question of which symbols and what they're doing and whether there's too much or too little at this point. I made tabs for all the APL stuff. It sounds like you guys are pretty much all familiar with this. This is Adam, his thing. He's a great resource, and we have an interview with him. But I just kind of, in preparation for this, I kind of laid this out for people who weren't necessarily familiar. Obviously, if you've seen it in the videos we've done, we've already gone through a lot of this stuff. But is there anything in here? You've used tryapl.org. This is dialogues. I think they need to make a dark mode for this. Color's a little strong. We've got the APL definition. We need to look at this. The wiki we've already seen. APL cart, which I believe Adam put out there. So this is the recipe list, which is quite convenient. You guys seen this thing? And there's a BQN crate for BQN. We've got the APL Orchard, which is a chat group. It's under the, again, Adam's the administrator of this. It's under one of the Stack exchanges. There's a Reddit channel, APL JK. And it's a pretty good channel. You'll see a lot of stuff from the Arraycast in there. People. I mean, it's a fairly close-knit community. It's a niche right? We've got to kind of support each other. There's the dialogue site itself where you can download the free version. GNU APL, when I did the Bye Bye Hello World, I first did it in GNU APL. I have a bias towards any tool I use, I want to build from source and I want it to be open source. So actually all the languages I use in here, with the exception of J, because I was having trouble building it, and dialogue, everything I've done so far, I've built the source of the tool and used that source build for it. And this was Adam's version of the Bye Bye Hello World. This is his one-liner.
What, I don't remember if you said it earlier. What's the Bye Bye Hello World?
So, I guess it was over a year ago, I kind of went on this rant about how I thought Hello World was the dumbest thing ever because it's just absolutely useless. And anytime a new language is presented, here's how you do Hello World. It's like, okay, great, there's a print line. Big surprise. It tells me nothing about the language. So I said, we need a better example. And originally I ended up calling it Goodbye Hello World. So that's what I want to say, just goodbye to Hello World. And I thought, just add a little bit more of the typical things that you see in a program, and it could still be very short and very brief, but give you a mouthful taste of the language rather than not even the taste of the language. And I started that project a while ago, and we've been making, Steve and I have been making, basically applying the same spec to different languages. APL was the second language. I did C, then he did PHP, and then then I did APL and BQN, and he did Erlang. Then I dived into J, Scheme. He's just done Elixir. We're going to release Elixir shortly. So the plan is we're just taking the same application and going through various languages and showing how it's implemented.
Yeah.
And this was only the second one, this was the one I did in APL. And this is my first foray in APL. I mean, I programmed it when I was 8 years old, but I've long forgotten how any of that works. So my struggle was to go through and figure out how to do it. And that's, when I put this out there, and then Adam put out a counter video saying, okay, this is how I would do it in APL. And he made 4 variations of that using dialogue versus using GNU, which is what I used here originally. So I don't know if you want to see any of that, but the videos are online. You can see the spec and basically how it works. It's a very simple program. All it really does is that's different is it takes a countdown. You can either put the countdown at the beginning and it says world hello, and however many seconds you count down, it goes 5, 4, 3, 2, 1, goodbye. So it involves taking input from the user, validating that it's a number. So there's error handling, right? If it's not a number, it's going to give you a prompt again saying this is invalid. It has an iterative loop, right? And there's a little bit of timing in there. It involves a sleep function. It waits for a second on each thing. So what we've found is we've applied it to like array languages and functional languages. It's not good at showing the strengths of those languages, because what is the spec? It's this interactive command line utility. So for doing I/O, for doing things like that, it doesn't show you going into a multi-dimensional array, doing sweeping calculations across it, and that sort of thing. So we've talked about other specs that we may want to do that address more the strengths of functional programming, the strengths of array programming, that sort of thing. So anything you guys want to talk about with APL in general? I've got tabs for the other stuff. We've only got one person watching right now, so this is more for us here, for us to discuss.
Maybe if he or they have some question, they can ask.
Well, somebody said hello, but I don't see any
If
questions
I
popping
don't know
up.
if they're still connected, but
Any questions, opinions, etc.? Question mark.
Either way, I want to say that thanks for the idea and pushing it forward, because I think the Bye Bye Hello World is a really good idea, because I struggle with it's so hard to get a quick taste of a language often. So I think the idea is really good and I enjoy it. I think it misses probably some. I think if it would parse some file it would add two things that are like often needed. You need to read some file, in the path handling and this stuff, and then do some calculation with it, some transformation, like basic, third column or like something like this. You would need to do some kind of the APL like transformation.
Yeah.
Some map or it can be like.
What I'm trying to decide is, because the trick is that it's small enough that it still fills the niche of this is the first mouthful of this language. And yet, to your point, storage, accessing storage, file I/O, well, that's almost an essential element in any software anybody's going to build most of the time, right? If we're talking about array programming, we're not dealing with complex data. If we're talking about functional programming, we're not really have a use case for functions as first-class values or citizens, unless that's just the style of programming. So the judgment call is, do we expand the single spec or do we make multiple specs? Do we have a file I/O example? Do we have a web example? Do we have an array data manipulation example? I think I'm leaning towards not expanding this to keep it so rudimentary. Maybe it needs to alter in some way, but I like that it's almost always a page of source, like at least it fits on a screen. And that's why I get into debates with Steve, because he tends to subdivide into a lot of functions and it becomes a scroll. And if I cannot scroll and see all of it, I like that as this trivial example. But maybe it could serve as a foundation for a collection of examples. But then the problem is, when did we become Rosetta Code? Because Rosetta Code's already out there. So the problem I see with Rosetta Code is there's so much out there. If somebody wants to learn a new language, where do they start? Right? They go out and they see all these volumes of things. I was just trying to plant a flag in the ground and just say, hello world's not good enough. This should be the minimal thing, or something like it should be the minimal thing to get your feet wet. And I don't know, maybe it was just a bad attitude on my part. It just always drove me crazy. Hello world in this language, okay, great. It's like,
do you have
nothing there?
That made me think a little bit to the side. Do you have examples of like parsing data in APL from something like mapping over a CSV or something like that? So one of the things that I'd always had in the back of my head is like, I feel like there's something interesting in like, feels like the array programming language paradigm has a little bit in common with a lot of command line utilities, in that there's a lot of things that sort of implicitly operate over lines of input and apply a function to each line of input and then give you the output. Kind of this is like the most basic thing you do with a command line a lot of the time. You grep, you transform, you have tools like trim, the trim function or whatever else. And so I'm curious how that looks. Like, or like awk, where you have this implicit operation of apply this regex as a filter to the file and do something if it matches.
Well, it's interesting that you bring that up, because one of the things I felt that I wasn't doing justice to in this whole meetup was I don't have a lot of good examples of ABL code yet, because it's new to me and I'm starting to apply it to various things. But to your point, one of the reasons, so the main project that Steve and I are working on is Proglang based. It's going to be a website that categorizes programming languages across the board, not just array languages, but provides factual details in a way that's not available out there, where you can filter and sort and exclude and include and compare language to language, like show me all the ones that have mutability as a default. Okay, exclude ones that are not this, exclude ones that are not that. Just a really good resource. And part of building that, I realized it needed a data model of the data behind it, right? What's all the data? It's multidimensional. So I saw a use case for applying an array language. Now, the website's being built in Erlang. because of the beam and the robustness of building a service using Erlang and Beam. But the data model, Erlang isn't the ideal case for that. And I started writing code. This is a simple example in the beginning of just taking a comment, like you said, CSV data. Here's CSV data, right? Literally in GNU APL, one of the limitations of GNU APL, I actually want to switch to, let me see if I can switch to source mode here so people can see what we're talking about. I want to go to MacVim. This is what we're talking about here. Okay.
So is there any bump too?
Yes, there is. Sorry, it's
Right here?
just to your left, yeah.
Yeah.
Right there.
Like this door.
Not the one,
right? The Windows line, right?
Yeah, no sign.
Yeah. So let me increase the font size on this so it's zoomed up for us. You can see this a little bit better. So this is GNU APL, and one of the downsides of the GNU APL is it doesn't have a good way of, in the code, to declare like a CSV. You have to put it in a string. So this is actually just a multi-line string. Like there wasn't a good way to, you can strand on a single line, but I couldn't figure out a way in the syntax to have a table, have a matrix. So I did it in a string. But then what I wanted to do is I realized, okay, I need to generate the HTML for this string. That's what this program does. So it's doing what you're saying. It's starting from a CSV in a single string, and literally just going through this expression right here. So rows, there's a bunch of debug stuff in here because I was debugging, and you can see I actually put the keyboard in there just so I can cut and paste the symbols. But rows is it's a multi-line string, so it's effectively just a straight string of characters. This expression is a direct function, takes rows. What is this? I'm trying to look at what this actually does. I think this just puts it into an array. Yeah, this is the raw data. So this program takes the raw data that's built there and passes it to this function I defined in right there that wraps it, that literally wraps it. And I'm realizing I could just model the data kind of as a CSV and then do all the decorative stuff that's needed for HTML and classes and all that stuff using code to do it. But I looked at GNU APL and, it's like, okay, it's kind of clunky and awkward. But as soon as I go to BQN, I can actually declare the table directly like this. So I've started to build up the multi-dimensional array where you've got a table this way, but then on certain columns, it's going to cut in based on other criteria like implementation. So I started coding it this way, and I could literally just type it all in BQN source, and then have it parse all of that and present it into a web page. It seemed like a good application for that, so I've started going down this road to do that. And BQN just has better support for, I don't know about dialogue, because I'm not using dialogue. I prefer to use the open source stuff. But I've already started to do this. And I haven't written the parsing yet for that. And I was playing around with doing also the same thing in J, because I wanted to compare the differences. And J has the ability to declare a matrix and source, as you can see here. So here I'm categorizing it by paradigm and memory management style and stuff like that. All of this is based on originally a spreadsheet I started creating when I was researching programming languages. It's what spurred me to decide that I needed a website resource to do this, because I immediately started making columns and various categorizing and subjectively deciding this is in that category and that category. And I was realizing it was starting to get complex, and it would be nice to have some dynamics to it. And I'm not going to sit there and write Excel macros or spreadsheet macros. I want to do a full website. I realized I need this resource. Other people might like having this resource. If it was out there, I wouldn't have to build it. So that's the direction I'm going in right now. But I haven't got very far with it. And you can see just the little sample I have right now in APL just takes this CSV, declared in line, but it could have obviously read that from a file. And then you just do a run, and it just literally just wraps it in the HTML. And I can imagine a lot of other functions for doing the querying and that sort of thing. So we're going to see where it goes from here, but that's how I'm building it. So I think there's potential value there. Now you do a lot of, or you do some data science, right? That's what you're using.
Yeah, my major is data science. So
Okay.
yeah.
So so you definitely have some use cases where it seems like array programming is very useful.
Well, that's what I want to explore. Like whether there is some huge benefit of array languages that the NumPy cannot already do, because like the things that I struggle with NumPy or like pandas is that usually it's like slow or not performant and stuff, and then there is the Rust library polars. So that will definitely help me, whether like using some combinators and whether they are like implemented there in any way will help me in the job.
Yeah.
Not sure.
So
We'll see.
NumPy is slow? I thought it was a C, isn't it a C library, C implementation, or is it all written in Python?
No. Like underneath NumPy is written in C, I believe.
I think there's, going back on topic, I think there's Fortran in there too.
Yeah. The math algorithms, such as like the matrix inverse and this stuff, they are, I believe, implemented in the LAPAC library, and it's Fortran. So
So it's compiled Fortran.
yeah.
Interesting. And then Rust has got Polar, which is a rewrite effectively of the...
Well, that's like a little tangent. Polars is rewrite of pandas,
pandas.
and pandas underneath the hood built on top of NumPy. So I believe that Polars built on something which is in Rust called ND array or something.
And they're doing that for performance.
Yeah.
Okay.
But it's a little bit different because the polars are like lazily evaluated, while the
Like
NumPy is
Haskell.
eager evaluated.
Interesting.
So I don't have the experience with polars yet, but so far I saw the videos. It's that I believe you define the pipeline and then you run it in the end. While in the NumPy or pandas, which is not the same thing but the same paradigm or like the same thing, you just do the stuff one by one and it slowly eat all the memory until you run out of it.
Huh. Interesting. So you've the use cases that you're thinking about for array programming.
Mostly just curiosity and
Curiosity.
wanting to learn things. I mean, I think there's something interesting. The idea of, I thought I mentioned this idea of a lot of command line tools and text processing tools being sort of implicitly array-like in the sense that they're operating on a series of lines and implicitly mapping over them. I thought there might be something interesting to steal there. A long time ago, I wanted to, well, I still want to, but I don't think I'll do it. Write a new shell. So that's one of the connections that always is in the back of my head.
Yeah, I had exactly the same thought 2 years ago, and I've been leaning in that direction too. Yeah, we should have a conversation about it because I've been looking at using Emacs as a shell, like forcing myself to go from Vim to Emacs, and why isn't like a scheme or a common Lisp or something where a true language is built in? Because personally, the Bash programming language, the shell programming language, POSIX shell, is so aggravating to me.
I have a theory, which is that the syntax constraints of a shell are actually really severe.
Oh, really? What?
Really severe. So you have all these constraints that don't fit well with the ways that most programming languages look. And anything that looks like a traditional programming language, or even an untraditional one, depending on what you want to count as traditional, a scheme or anything like that, is not going to work well. I think you want You want things like the ability, you just want to be able to type rm space star and have that mean remove everything in the current directory, right? You want to be able to type ls dash lart and have that run the ls command with those option arguments. So you need this thing where you have the ability to type in strings as unencoded characters by default, and you have the ability to have the first word in your command or in your line be the name of a program that you want to run. And if you think, and then if you work backwards from there to then, okay, so what does that mean about how my syntax looks? It's going to look very different from any known language, and you're going to have to make some compromises. I still think you can do way, way, way better than what Bash ended up with, right?
Yeah.
But I think that's sort of a thing where like a lot of people go in and they're like, oh yeah, we're going to use scheme. You know, we're going to write a list like shell. And it's like, I'm sorry. Actually using that is going to be very frustrating unless you support kind of like the interactive use. Because I do think you want something that is both suitable for interactive use, the way we use a shell, but also suitable for programming. Or for doing, and not necessarily general purpose programming, like maybe it's never going to be a language that you particularly want to write a website in. But at least, you know, structured programming where you're calling functions and having if checks and, you know, things like that, and not tearing your hair out because the bash syntax for all that is terrible.
Yeah, this could be a whole discussion, because your point about using a full language. I mean, Emacs has eLisp right built into it, which is effectively a full language. Oh God, I don't have power plugged into my laptop. I better plug it in. So one of the things I'm on a rampage about right now is minimalism. I spoke about that in the ArrayCast interview about the complexity. I feel that the biggest problem in software development right now is just a crisis of complexity. It's just gotten way out of hand, and for me personally in the work that I do. So I'm going the opposite end. Rather than taking like the Ruby on Rails approach, like for building the website for Prog Base, rather than taking a big framework where everything's built in and I can just, you know, fill in the blanks of my template and get the thing up and running, I'm going from the opposite extreme. What's the least amount of software I can use to get things done? And I'm applying this across the board to everything. It's an example of why when all the tools that I have are all sitting here in this one directory, and they're all built from source. I have a shell script that builds each one. I literally just type in build Erlang, puts it in this directory. The executables in the source, nothing is installed. I don't like having anything installed into shared directories. And none of that makes sense anymore anyway, because there aren't multiple users in operating instances anymore. But I don't even contaminate my path. I don't add things to the path. What I do is I put symlinks. I have a path to one directory right here. And whenever I build a system, I make a symlink that gets added to this directory. So I don't have to worry about colliding, you know, some binaries in some path colliding with some binaries in some other path, and they don't know about each other. I literally just have a set of bash scripts. I build everything. I'm about minimalism. What's the least amount of tools I can do to get everything done? Again, I'm trying to, for myself, reduce cognitive load. I don't want to have to think about more than I think about. So one of the things I did recently as an experiment is for deployment, I'm still using Ansible, which sits on top of Python. And I have a few scripts that are written in shell to call Ansible. So it's still a layer of technologies. You've got Python. You've got Ansible, which has its own declarative syntax. It's a YAML format, right? So it's a language. So you have to think about, you don't have to really think about Python, but it does run on Python. You have to think about Ansible. Then I've got shell scripts that launch the Ansible scripts, so you have to think about how that's written in. So as an experiment, I rewrote one of my shell scripts in BQN. Because I'm looking for, what could I use as a scripting language right now, other than Bash, I want something very lightweight, has a very small footprint, it's fast, it's quick, and maybe if it's in a language I like programming in, would that even work? So this is an example of a rewrite of a shell script in BQN. And the nice thing about CBQN is it's very small, it's very lightweight, it's very fast. This executes instantly. So, I mean, actually, there's a way to even condense this. Apparently, there's an operator in BQN. I learned about it after I wrote this. Well, it'll do prefixes and suffixes for you. So all this does is, let's see if I can show you. It looks like. Yeah, there it is right there. 5. Okay. So this is DevOps stuff that I've written in Ansible. I've been using for a couple of years. And if I want to deploy a server, I say a play. And what it does is it goes out and it finds a bunch of playbooks. So I don't even have to do the list. If I just say play, then I can just say a play the playbook. You can say a/play and just give it the name of one of those things, like a stun turn server that I have as a playbook. And I try to make things as turnkey as possible. I want the fewest number of commands, the fewest things I have to remember, fewest things I have to know. So the original play is a shell script, the old one, but I rewrote it in BQN because I wanted to enhance it. And I thought, here's an opportunity. Let's see if whatever I can do in POSIX shell, I can do in BQN. And the other thing that I liked about BQN is it would be a language that in whatever environment I use is consistent. One of the problems with shell is, well, if I'm on Bash or versus Z shell that macOS decided to switch to, right? They used to be on Bash, now they're on Z shell. I go to some other environment that, can I just install BQN anywhere I need it? On a Linux server, on a Windows machine, on macOS, on a Raspberry Pi, wherever I want it. Is it small enough, lightweight enough, easy enough that I could consistently have the same scripts everywhere? And this is an experiment that I'm trying to use to do this. And
How heavy is Bash?
What's that?
How heavy is Bash? Like how big is the Bash executable?
That's a good
It's
question.
got to be really portable. It's probably not. It's interesting. I never even thought about this, but you could, if you've got a server where you can deploy executables, you could deploy your own version of Bash. No one does this, but
No, you're right.
that would, yeah.
Let's see, I just wanted to show you the diff between the Bash and this.
Mhm.
But anyway, it's a simple shell script. So this was an experiment. I was thinking, because I am looking for I was thinking the same thing. One, I want a better shell, but I really want a scripting language. I've been doing scripts in Ruby. I've been doing them in Python. In fact, I have a set of scripts in a variety of languages. I've got some in Ruby, some in Python. It's like, there's times when I think polyglottal is useful, and sometimes when it's just annoying, right? And for me, it's mostly been a result of generations. So this is a little repo that I just put everywhere. It's just got all of my stuff that I use from the command line I've had for a long time. And you can see, right? Some of it's in Bash, right? Some of it's in Python. Some of it goes back to Ruby. I've started to rewrite Bash stuff so that it's truly POSIX shell, so it's not specific to Bash, because I was running into problems with Z shell. So all this stuff that I build, here's an example, right? If I want to build a language, there's build CBQN right there. And this is shell.
The horrible thing I do is I wrap even trivial build scripts in make. So I'm not using any of the functions that make does for dependency tracking. I'm not using any of the syntax. I'm just making it so that I can have make build and make clean and maybe make some other command.
Yeah.
But it's as dumb as, I guess I'm not doing this for my Rust projects. I haven't been doing that, but like, yeah, I'll have
yeah, I guess, I don't know. I'm not doing this with Rust, but like I literally have a, I'm forgetting the example, but anyway, I have, that is just like a standardized entry point. And not because I think Make is particularly good, but just because it's,
Well, you're choosing a tool
there.
that's, for the most part, ubiquitous.
Yeah.
I mean, that's the whole rationale for writing stuff in shell is I don't have to install anything. If I go into an environment, it's going to be there, right? It's there on Mac, Z shell. It's there on all Linuxes, mostly Bash. For WSL and Windows, if you've got an Ubuntu installation, it's there as Bash. But I just find the language and the syntax, particularly the quoting and unquoting, so painful to deal with. And so much of the stuff I do is string manipulation, string parsing, string assembling, and all that sort of stuff. And it's just I find it painful to code that. And I actually enjoyed thinking about it differently, the same thing in BQN, about how it's, like this basically just does an ls, and then it's looking for prefixes and suffixes, and then it's giving me a list of names. And to me, this wasn't more complicated than BQN, than POSIX shell. But as I start to dive into it, again, it's an experiment to see what I was trying to do the same thing with Scheme. I was trying to do the same thing looking at could I use Erlang. But BQN is really lightweight, and this is the shell script I used to build it. And one of the things you can notice is you just need Clang. I've been doing that with every language I've been experimenting is how much do you need to get, I'm really into bootstrapping, how much do you need to bootstrap something? I've run into several of the GNU tool sets where it requires this GNU library, and that GNU library, and that GNU library. And if you go to a raw Ubuntu installation or some other Linux installation, it's not there. You've got to add it to the package manager. This is lightweight. It doesn't require anything else. And it's small and it's fast. So it's getting a thumbs up for me for now. And again, it's a language I like coding in. But I like doing Scheme. I like doing Erlang. Erlang builds pretty easily. It was pretty much just a C compiler. One of the gripes I have about Rust right now, you can't build it from source effectively.
Yeah.
You actually go out, it has to download a pre-release version built binary from the Rust Foundation, meaning you're now dependent on someone else hosting it. Somebody has started a project that starts to build Rust from its original versions, and I was digging into that, but it's not really ready to go, and it's not really complete. So that's one of the complaints I had about it. I don't like being at the mercy of a vendor. I have strong objections to that. Or the internet in general. I would like to have a tool set where I could be completely offline and build everything I need. Right? I still come from the days when the internet was not a requirement, it was a luxury. And for myself, I don't like being too dependent on something that I can be cut off from in order to solve the problems I want to solve. I feel like being online is a nice option, but it shouldn't be a requirement. Maybe that's unrealistic, but that's what I said about being extremely minimal at this point. But anyway, I just wanted to show you an example of, we were talking about other use cases for BQN. It's funny how it changes the colors as soon as I switch. You can see I'm still just on regular Vim, I'm not using NeoVim. I don't think NeoVim has a GUI, right? I looked for that. Like most guys using it are doing it in a terminal window.
Who would ever wanted to use it? Like there is the GVim, right? The graphical.
Well, that's what this is. This is MacVim.
So
this is GVim. Yeah.
So then there's the GUI, right? You just using it.
Yeah.
I do it the old way that when I open my terminal and then I like type Vim, like whatever alias.
Yeah. But the real test case for what I'm doing is going to be progling base. Will this make sense to use an array engine for the data model and the parsing of the data model and all that sort of stuff? At some point it may go into a database, but again, if I don't need a database, I'm not going to do a database. So I'm being really extreme about what is the least amount of additional software complexity that I can add to solve the problem, rather than the opposite direction. Right? If you're going to build a website, most people are like, grab this entire framework, download it, fill in the blanks. I'm going the other way.
Yeah, I like the minimal approach. Like when you said it at the podcast, I was like, oh yeah, I really like it. Because the real world usually pushes you away from it. So when you have the luxury, you can afford it. I think it's a good idea to pursue it. You know.
Well, I do development of mobile right now, Android and iOS, and it's very painful. The dependency situation. I don't do any JavaScript web-based stuff. I used to do a lot of Rails stuff. Now I'm looking at trying to use Erlang and something based on Erlang or Elixir more likely. But do you guys do any web programming? Any front-end stuff?
Not really. I started as a front-end programmer and then moved back into.
It's just more enjoyable.
Yeah. I mean, I'd actually really like to get back into it, but just at the moment, I'm not in a position where I can really split time.
Well, people who do it, you talk about how painful it is in the dependency management, particularly on the JavaScript side. But I can tell you the mobile side, I don't know if you guys do any mobile programming, it's just as bad. iOS is probably less bad simply because most people in mobile prefer to stick to iOS. Like if they could, they would choose to not touch Android at all and just do iOS. Mostly because it is a walled castle. You know, the downside of Apple, everything's proprietary, everything's a walled castle. But the hardware you have to worry about all comes from a single vendor. I have a spreadsheet that's got literally all the iPhones and all the iPads, and it's this long. So you build an app, you only have to worry about those devices. And you can simulate most of them. Android, you know, thousands of unique devices in Android. And the ecosystem for it is a mess. It is just a mess of libraries and versions and layers and versions. And every time there's an upgrade from Google to anything on Android, new version of Android Studio, new version of Kotlin, new version of this, it is just a ripple effect of just, it's like an earthquake, right? It's just like cracks in the ground everywhere. The whole thing just shatters, and you spend days sitting there fighting version matching. Okay, well, they recommend this version, but I'm using that library, which only works with the older version of that. It won't work on the latest of this. But if I use the older version of this, it requires the latest version of that. You just spend days chasing that down every time there's a change. And the changes come because it's mobile, right? They're releasing new operating system versions every year, right? Next version of iOS every year, next version of Android every year. So you've got about a year of some stability. And then in that time frame, they're constantly throwing that at you. And it's just, it has nothing to do with trying to solve the problem you're trying to solve, right? The app you're trying to build, the features you're trying to create. It's just the turbulence of the thing you're on top of. It's just the shaking ground that is never stable. It's a nightmare. But there's really no way around it. So, not dealing with the mobile world, having an option to avoid that sort of thing, not, you know, have that kind of self-inflicted pain and try to do what I can for that. And then, of course, programming in Kotlin. Actually, it's 4 programming languages. iOS, it's Swift and Objective-C. Realistically, you still have to know Objective-C. If you pull up the header for anything that's in Swift, it's in Objective-C. And then if you're doing Android, it's Kotlin and Java. You know, you'd hope you could do just Kotlin, but no, you have to do Java. Which you said you like Java. Do you do any programming in Kotlin?
I have technically written lines of Kotlin.
Technically.
Yeah, I looked at some project and made some minor changes to it.
Switch us back over to the...
Yeah, Kotlin never felt compelling enough for me to spend significant time on it. Like it has some niceties, but you know, the standard libraries are written in Java for the JVM. Like so much of the JVM's own infrastructure, and I'm really interested in the internals of the JVM. So.
Oh, you are?
Yeah. So spending time in Kotlin didn't feel particularly necessary.
Yeah, I mean, this is the issue with Clojure, Scala, Kotlin, they're all on the JVM. Ultimately, it's a Java-designed architecture. In fact, one of the things in Kotlin that you can get burned by is things that should not be nullable are still nullable because it's sitting on top of a Java-based engine. So even though you think you're being safe, this is not nullable variable. If it maps to an actual Java variable in a library,
Yeah.
there's no protection, so you can get burned by it. But we're not here to talk about Kotlin. Well, unless you want to talk about CAP, which doesn't sound like we're interested in that. Have you guys seen WeWeb? Have you checked it out?
I only heard the 2 or maybe 3 episodes with Kai, so I've never seen it in like line of code with it, but
I've heard the name, but that's all.
It's a funny name, right? WeWeb. He said he came up with the name because he liked the sound of it. I've not written any code yet in WeWeb, but Steve's going to sign up to do Bye Bye Hello World in WeWeb. We'll see what happens. But they're all very excited about it. You can see it's symbols, just like APL, BQN, but they're uniquely designed. It's not J. So J and K both restrict themselves to typable symbols. So J and K are both that way. And then Q is K with keywords. Because I think they try to teach people to use the KDB database, and they use Q as a language. Kai decided to go with symbols. He's got a few more. It's different from APL and BQN and J in that this is stack-based. I don't know how much you followed with that. And so there's some similar languages out there, Factor and Forth, that are stack-based that are not array languages. But I'd say one of the selling points in my mind to BQN is how great the presentation of his website is. Every one of these is an interactive REPL. You can literally tweak the code right in here. Like we could say 99. This will actually slow it down. And WeWa is written, the compiler is written in Rust. For me, that's a downside.
well, what would you choose? Because right now, before you said whether your name is Jason? Justin, so sorry.
Jason. Yeah, it's okay, Jason.
There's the joke with the Vim key binding. So Justin's favorite language, and he said he doesn't have a favorite one. So my favorite now is Rust. If I can choose one, I choose Rust. You said Rust has some downsides for you, one of them being that you cannot build it from source. So what's your favorite? Is the scheme or like?
Well, I told you my 3 favorites were.
Well, you said BQN.
BQN, Scheme, and what was the third one? I remember Erlang.
But really, if the question was you need to do some
systems level programming.
No, like broad thing, you need to pull some data from the internet, do some transformation, put it to the database, do some logging in case something happens, and yeah, that's enough.
Yeah.
You do this preferably in BQN. I don't know in BQN.
Like you can see what I'm doing. I'm starting to rewrite shell scripts.
No, like
BQN.
You can write all the libraries and stuff in BQN probably, but are they there like for the databases, logging, and this stuff?
I don't know. We're gonna find out.
So probably not BQN. So you would do it in Scheme or like?
Favorite doesn't have to be what you'd use if someone held a gun to your head and said you've got to solve this problem in an hour.
That I misworded. I didn't. Yeah, you're right. That was like bullshit on my side. The question was like.
No, your question is
not like what's your favorite tool of like for any job, but when I give you the job, do you have a favorite tool to do it?
So your question is totally valid. In fact, it's exactly the question I'm asking myself. I want to program in BQN. Where can I use it and not use it? That's what I'm trying to find out. That's why I said, can I use it for a shell script? Okay, it looks like I can. Can I use it for something I would use Rust for? I don't know yet. I have to try to find out. Can I use Scheme for that? I don't know. Can I use Erlang for that? I don't know.
So what would you do if you had a deadline tomorrow?
Because right now I have a backend server written in Rust. So I have production live stuff written in Rust. But I wrote it in Rust because at the time it seemed like a good choice. Now I'm looking at it going, I'd much rather that be in Erlang. Because Rust is not sitting on top of the beam. It doesn't have any of the fault tolerance of the beam. It doesn't have any of the live redeployment of the beam. It's not interactive. It's not very high level. But it has the memory safety and it has the speed. But for this particular service, I don't know that I even need that speed. Memory safety is always good. It's not a bad thing. Of course, that's also solved with the garbage collector. So it's a question of, one of the things what attracted me about Rust is I came from the C++ world, where I wrote a lot of very high-performant code, 3D engines, right? Like the Unreal Engine. I've written 3D engines for companies. I have my own 3D engine. I've written stuff like that, where you're doing things 60 frames a second. You can't waste anything that you're doing. Right, I've spent time tuning a renderer so that it could do what's called batch rendering in a multi-processing way, so it can process one set frame while it's still rendering another part of the frame, just to squeeze performance out. So we're talking about high-performance applications. So coming from C++, where I have total control of everything, right? It's C effectively. So Rust looks like a better C++. It was very attractive to me at the time, 2015. Provides the kind of memory safety. Zero cost abstractions, right? There's no overhead to an abstraction. That's what you want for system programming. No garbage collector. Remember, I don't know if you were around in the early days of Rust, but they were still toying with the idea of having a garbage collector. Yeah. And I was right there seeing what they were going to do. I'm like, are you guys going to put a garbage collector in? I don't think you should. It's a system programming language. You're going to write a browser, you're going to write an operating system, you're going to write a driver, you're going to write a rendering pipeline, that sort of thing. You want total control of every little instruction, of every little possible overhead. The truth is you don't actually need that control all the time, but you think you do. The truth is that in any software, even renderers, there are true parts of the system that are the bottlenecks that have to be fast, but most of it doesn't. For example, Unreal Engine. Most people don't know this. Unreal Engine has a garbage collector in it. It's their own. They use C++, but they built their own garbage collector. All the actor objects that are in the simulation are garbage collected. And it runs fast enough to do the most high-performance, high-fidelity 3D graphics for AAA titles with a garbage collector. It's just very clever where they use it, where they decide to use it. The render pipeline doesn't get caught up in it, that sort of thing. So the reality is, people think they need high performance all the time. They don't. But when you need it, when you really need it, like for example, you said the NumPy library as an example, you were finding that certain applications of it were slow, and you're trying to use something like Polar or something that can maybe relieve some of the overhead that you're experiencing?
I think there is like different problem, but it's the same direction. Because I think the bigger problem with NumPy isn't any garbage collector, because there's like the math is being done in the C below, so there is like none. But the problem is that there is no I think there is like little optimization of the steps. That if you call like method, it will like each of the methods will be like underneath solved like the optimum C code, but
the chain of methods,
the chain of the E could be like
yeah. So there are reasons. So the point I was making about Rust is it looked very appealing to me at the beginning because of the type of programming I was doing. It was going to, for me, no question, I would program in Rust before C++ if I had a choice. In fact, it was only 3 years ago, I was trying to figure out how to use it in Unreal Engine. A couple other guys were doing the same thing. Because the C++ in UE is miserable. It's not just C++, it's bad C++. It's not, they have a very old code base. This code base is several decades old. It was written back before there was C++ 11. They had to build a lot of their own stuff, so it uses the preprocessor in a really ugly way. It's just not fun. So me and other people are like, if we could do this in Rust, it would be great. So we're figuring out ways to try to create a Rust binding and do all that sort of thing. So there's no question, if somebody said, you need to write software where C++ would be a good choice because of its ability for performance, I would use Rust for sure, or maybe Zig. Something in that class of languages, right? Zero overhead, zero garbage collection, some level of improvement of memory management safety. But for most things I'm doing now, again, back to the, what was his name again? Forgot the name of the guy with the dead programs.
Jack Rusher.
Jack Rusher. I think more software should be interactive than is, at least the stuff I want to build. The batch cycle, the building cycle. Rust is not interactive, right? It's build, deploy. One of the nice things about, and Erlang is not truly interactive, it's a compiled language, it's not interpretive. But it's a live environment where you can literally go up, modify the code, and immediately deploy that code in a running environment. There's no deployment cycle, there's no test cycle. It is what Bob Terrio called building the plane in the air. It's the small talk model. The ability to modify code on the fly is very attractive to me. And then also, we should program it as high level as possible and only drop down to a low level where needed. So when you do need to write that fast routine, and that's what people are doing with Rust, right? They're writing code in Elixir, but they're like, unfortunately, this part of the system is really slow because it's a series of function calls going through an interpretation cycle or whatever. We could take that out and make that a module in some low-level language, Zig, Rust, something fast. C, of course. I mean, C is the universal language, but then, as I said to Steve the other day, C is somebody handing you a set of scalpels, which is great, very sharp, but very likely you're going to be bleeding on the floor with it. But, BC, it's a great benefit. Most of the things I'm building that I'm using, Erlang, it's written in C, Scheme, written in C, BQN, written in C. So as long as there's a Clang or a GCC that I can use, I can bootstrap these things. As soon as they're written in something else, and this is the point, Wewa is really cool, written in Rust. So I have to build Rust, then I have to build Wewa from Rust, and then it's that. Violates my bootstrappable rule. But I'm still using Rust. And I may still try to finish that project. It's a thing called, what was it called, MRust? Some guy went back and he set up a system where you get a really, really old version of the compiler because you have to basically build versions off versions off versions. What they do is it's half of it's written in Rust, but it's written in prior generations of Rust. So you've got to start from the beginning.
GCC is working on compiling Rust too. There's work on the GCC backend, so that's probably, I wouldn't be surprised if that ends up being the eventual build, bootstrapping story.
You're talking about LLVM?
No, GCC.
They're generating a Rust backend.
There is going to be not a backend for GCC in Rust, I guess front end actually to GCC to compile Rust code. So,
okay.
They're going to make GCC support compiling Rust code.
Yeah.
Is I believe intended, because I think everybody sort of realizes that eventually you can't just stick to the targets LLVM supports because it doesn't support enough architectures and everything.
Yeah.
And people like the idea of having a second implementation.
Well, that's another problem. My opinion, an issue for Rust is that it depends on LLVM, and there's a movement to get away from that. Zig, for example, is rapidly getting away from it because a large part of the slowness of Rust is LLVM. In fact, Richard Feldman, I recommend if you're interested in that, he's got a podcast called Software Unscripted, and he uses Rust. He built Rock in Rust, but they figured they're writing their own linker and stuff like that because they've found, doing a lot of performance analysis, most of the overhead of the compiler is LLVM, and that's a very deep, very old code base that's been around a long time. It's not likely to be tuned up or rewritten anytime soon. And one of the main strikes against Rust is the compile time. It has a very slow compile time, in a large part because of LLVM. The other part, of course, is the borrow checker and everything it has to go through for that. But there are things I don't like about Zig either. It's like there is no perfect language at the system level as far as I'm concerned. So
It's time to write your own one.
Well, that's a whole nother story. I am dabbling in doing a language design, but not one to replace Rust.
Too much work.
Yeah, so that's what's spurning me on to the language experiments. I selfishly just want to write code the way I want to write it, because it feels like to me in software engineers. I mean, this is kind of binary. There's two philosophies. There's people who say The language doesn't matter, syntax doesn't matter. Even Jack Rusherman, his thing, he made the comment, he goes, people worry about syntax, who cares about syntax? Like, he doesn't think it's a big deal. To me, it's a big deal. Steve is the opposite of me. He said himself, I'm a solutions architect, I don't like any one language over another, I just use whatever tools works for the job. But I spent so much of my life writing code, and I spend so much of my life writing code, no matter what problem I'm solving, that's what I'm doing minute by minute. I'm typing in these characters. I'm reading these characters. I want that to be as enjoyable and as smooth as it can be. So the syntax matters, the semantics matters, the tacit versus not tacit matters. It's a personal thing for me. And the analogy I make is carving wood. Yeah, you can carve wood with a screwdriver, right? And if I had to go carve wood for 5 minutes and I wasn't going to do it again for 2 weeks, I'd use a screwdriver. But if that's what I'm doing every single day, if all I'm doing is carving wood, I'm going to get the best wood carving tools I possibly can for that job. And to me, the programming language is the tool that I'm using day in and day out, and so it does matter a lot to me. But I respect the other point of view of it's just a tool. Figure out which one fits pretty good for the problem I'm trying to solve. What matters most is the problem that I'm solving, how I'm solving it, how I'm thinking about it. I get that. But
I'll put my troll hat on and say, once you understand Turing completeness, you understand that only syntax can matter because, you can just implement whatever you want in any language. So the syntax is
or
what
like the
differentiates
calculus.
them.
Yeah. But that's the argument I was making earlier about symbols. People say, well, I don't like symbols. Well, you obviously like some amount of symbols. Unless you're programming in an LLM, you're putting in a semicolon or a parentheses or something somewhere in there. It's not a word. So it's not a question of if, it's a question of how much is too much. What's the right amount? And to your point, what is the right notation and how does it look? So it's fun. This is fun. I'm having fun doing all this. And
I think you made a point for the semantics, but also for the syntax. If you have a mug that you drink from every day,
yeah.
you usually will not have the ugliest, most uncomfortable mug on the whole planet. That will scratch your skin and stuff. You will usually have some okay mug that's good to drink. It's just about the right size, just a good color. That it probably won't be an object that you hate the most, you'll probably pick a pleasant mug that you can drink every day from. So, and the syntax is for me this, you can have horrible syntax, but why if you can have pleasant one,
Not only that, of course, no matter what language syntax you write, your code can be ugly or good, right? I mean, how you write the code itself, that's the art of what we do, that's our craft. And some people care about the shape of it. I'm very into aesthetics, I'm very visual, I like code to look good. There's people that make the argument, they made the argument to me years ago, they would say, it doesn't matter what it looks like, right? Who cares what it looks like? The users don't see the code. You get the most ugly band-aids ever, but what matters is the UI and the UX and the experience and the solution, and to waste time thinking about how the code is, well, that's great until you have to maintain it, or change it, or enhance it, or support it.
So I guess you don't
Or you
use
write it.
auto formatters for stuff.
I prefer to format myself. Yeah.
Understood.
We would not work well together.
Well, there's a difference between when I'm a member of a team and when I'm writing my own code.
That's fair. That's fair.
Because I do a lot of consulting and I get added onto teams all the time. I always fit into I try to, if I add code to a project, I make my code look like the project.
Nice.
When it's consistent, and it's rarely consistent. A handful of people, you can see it all over the place.
You find two inconsistencies, you're like, no one even cares, I can do it my own.
Yeah. No, but if I was on a team of people using an auto formatter, I would use the auto formatter. As that's a responsibility of being a good team.
Hopefully it's in the pipeline so you don't have any
For
choice.
the code I write that I control, that's my code, no, I do it my way.
Actually, I say that, but I have a bunch of personal projects that don't have an auto formatter because I work in different languages sometimes, and just setting up that shit does not bring me joy. Everything related to configuring editors and computers in general is pure pain to me.
Yeah, the admin it's painful. I agree. That's why I want like a turnkey script where I can just go do that, just make it happen.
I do like languages that have a lot of formatting built in, which is
Well,
I think
you would like-
that is I think one of those things that's just going to be standard for things being built nowadays. And you can't do it through whole language because people have already developed their habits and nobody wants to see a 5 million line diff on their project that's been running for 20 years when the language starts auto-formatting.
Yeah, I had to explain that to somebody who was on a team with when they were doing their Git commits. I said it was very important that you never reformat as part of the change because then you can't see the change. So I said, if you're going to reformat the code, if you're going to run it through a formatter, make that its own commit separate where there's no changes to the code at all, just reformats, right? So that diff can be ignored. Then the code, because what was happening is they would combine it in a commit, right? They'd reformat a commit and suddenly, like you're saying, it's like, well, that's useless. The diff is now useless. So you might like Weewa because one of the things that actually Adam gave Kai a hard time about, you don't have a choice. It auto reformats. And it actually modifies the source. There was something about that. Maybe I'm getting the details wrong. But it was built in that if you write it, what was it? Oh, no, what it does is you can write in the words instead of writing the symbols, you can write the words using the REPL. I could do it if I knew how to do it. But you could watch their videos and they can demonstrate that. I'm sorry, you can write Weewa with keywords, and when you run the compiler, it'll replace the keywords with the symbols. So it auto-formats in that way. And Adam was like, you mean you give it a source file and then it changes the source file? He's like, yeah. Isn't there a problem with that if the source file is not writable? Rock, he would totally agree with you. One of the most important things to Richard Feldman was having formatted that. So Go, right? These are languages where the language provider provides the formatter as part of the language. And in fact, I think in Rock and other things, it's like a default or something like that. Like you have to turn it off if you want to. You have to opt out of it instead of opt into it. And then of course you got Rust format. So.
This is a real good point about reformatting and doing changes into separate comments because I was the one always doing that. That exactly. When I found that the reformat changes other things than the line, I did first the reformat, put there the commit, just like reformat it, and then I put there the change. But now it happened to me last week in Rust that I changed the way the code is structured, but in like kind of like small way, that there was like mutable variable and instead I return it from the expression. So there was like change of the last thing, and at the beginning there was just like let the variable equals, and there was like if let or something, which the if let was previously on a separate line. So it was like tiny change, it was like 2 lines. But this change made the cargo format shifted a tab to the left or to the right.
Yeah.
So now it changed like what? Like, I don't know, 40 lines? And I couldn't reformat it before that, right?
Right.
And I was like, yeah, this is ugly. I hope that people will understand that I just changed the header. So it was like, the header and the return statement, or like the expression at the bottom. And the rest is just like shifted,
Yeah. There's a whole set of tools that are designed to give you semantically aware diffs, so that in that section it would, I think, theoretically collapse it to, these lines just got de-indented or indented or what have you.
That would be very helpful.
Well, the only like indented and de-indented is fine because GitLab, the place where we see the diffs, shows this. That there's like the whole line is like light green, but the dark green is only the 4 spaces. You're like, okay,
Right.
so that. But if you add or subtract 4 indentations. Some of the lines, because the how to say the cargo format is quite aggressive, it puts the line back or it splits the lines.
Yeah.
So the 4 spaces makes difference, you know, and that's the thing. That's not it's not only 4 spaces left and right. It's like changing the lines as well.
Right.
And adding and
splits the
subtracting
line.
brackets, you know. It not only splits, but it also joins, you know. So that's non-trivial.
I think there are tools that can detect that kind of thing, but I don't know.
Some-
It might not be
Some language server addition or
something like that. I mean, like there's the term to look for is like semantic diff tools, I think.
Okay. Yeah, that
And
definitely.
I have a coworker. I've really not used them. I have a coworker who swore by the one he used at his old company that like it was wonderful, and it was a paid product, and then they stopped selling it as a standalone product. But there's that idea. I would just say practically, like the thing to do is on your MR, right? This looks like I changed 40 lines, but it's all formatting because because the formatter did that. Like a surprisingly effective thing is when you write an MR, if there's any part of it that's not just like trivial, you write, this is what I did, or like the actual change that matters is in this file. These other 4 are just because the method name changed or something like that. Just stuff like
Yeah, I'm kind of in the minority list of people I've worked with. I spend a lot of time on my commit management. I write very descriptive comments, and also what I typically do is I do a big block of work. I make a work in progress branch. I just call it whip something, and I say whip save 1, whip save 2, whip save 2. And then when I'm done with the work, I make a new branch and I start making meticulous commits of changes. And sometimes if I have a bunch of commits in a single file that are different from each other, that relate to different things, I will isolate them as separate commits because I want to see the progress of work. And I totally rely on Git history as my understanding of code. I don't put a lot of comments in code. I try to make code that's readable without comments. To me, the more semantic information I like to see is in the evolution of the software in the Git history. So I 100% rely on my own history. When I'm going back through my own projects, if I want to understand why code works, I look at the Git history and how it got there. I look at, oh, this was that, and that was that, and that was that, and I can see the diffs, and I can see the explanations and the rationalization, and see the history of it. I use it as an absolute development diary to understand the rationale and the architecture stuff, but it takes a lot of time to do that, to break down the commits. And I also do it for other people. I'm not a fan of getting on teams and somebody just says, fixed, you know, and they're like 12 files, you know, fixed X. Okay. You know, there's a lot of changes in here. Why were they made? What are they? That sort of thing. So that's just my personal peccadillo that I deal with. But yeah, the Git history and commits and all. It's funny, you guys both said merge commits. So you guys use GitLab. You don't really use GitHub.
Well, I use both. So I use the terminology that's used where I work.
In your company,
Yeah,
works
like
together in GitLab.
I was saying, you know, pull requests for a long time, and they're like merge requests.
Merge
I'm like,
request,
okay,
yeah,
merge request.
MR. Yeah, I have accounts on both. I mirror stuff for redundancy and also I prefer GitLab.
I do personal stuff on GitHub, and work is on GitLab.
Exactly.
Okay.
Yeah.
Because they can self-host it.
That's
It's-
funny. It's the opposite for me. Most of the people I've worked with, they have their stuff on GitHub, and I keep most of my personal stuff on GitLab. All my private stuff I keep on GitLab.
I don't know if GitLab existed when I started using GitHub, so I'm not going to migrate it. I also don't actually like GitLab much. I'd say it's really good for them that nobody evaluates them on like their ability to handle things like pull requests. Like the editor, the like web view for merge requests is just kind of janky.
Yeah.
In various ways.
I think both sites are horrendously overloaded with their featureitis to the extreme. It's hard to find anything, and they've changed it over time. They keep moving things around where repo information is and stuff like that. It's in chaos, but we'll deal with it. Well, main thing I want to ask is, so we got 20 more minutes left. I mean, you guys can leave anytime you want, obviously, but have we addressed questions or things you're interested in talking about in terms of why you came here today? Is there anything we've left out or you want to say about any of this? I just wanted to show Weewa at the end. I'm just like you. I've watched the Arraycast. I've watched them play with it, and it looks kind of cool and fun, but I've not dove into it yet. These are the diagrams of the combinators. You were talking about diagrams of various combinators.
Wait. Are they calling identity a bird? Symbol, bird?
Well, so do you know about the birds? You know about the whole thing of birds?
About the birds.
Okay, so the birds thing is combinator. So right, we've got the diagram. We get the combinator languages, the array languages, and so there's some overlap, but they're orthogonal, right? Obviously, right? Haskell having combinators doesn't. They're conflated here, but they're orthogonal concepts. So one of the big things that Connor does a lot is introducing the idea of combinators across languages. There's a book called Tamaka Mockingbird that goes back when combinators were defined purely in terms of mathematics before even programming. And bird names are given to the various combinators.
Okay.
So they're actually, let me bring up his site. Let's do that. Let's just bring up his combinator site. I think it's under array. Combinatory logic. So Connor has this website. It's called combinatorylogic.com. There's a home here. He talks about it. He's got this great YouTube thing. It's definitely worth watching. And he addresses APL and array languages in terms of how they deal with combinators. But here he's got a table. And the idea of combinators in lambda calculus, in functional programming, and math have been around a long time. And there are different ways to label them, name them, or express them. So one way that you often see what's called SKI. So because there's an S combinator, there's a K combinator, and I is the identity combinator. And supposedly all the other combinators can be built up as a combination of those three. Actually, they can be built up as a combination of just S and K. So if you just had S and K as the fundamental building blocks, all other combinators are achieved by combining them in various ways. So that's one way they're notated. Then there's a book called Tamaka Mockingbird in which bird names were given to them. So here's the bird names for the various combinators. Here's the SKI, and the SK names. I guess there's B's in there as well. Then there's just the single letters that they've been given to. So the I, the K, I guess that's pi, the W, the C. So you guys were talking about flip. Flip is the C combinator. Yeah, there it is right there. So there's Haskell, there's BQN, there's APL. And you can see there's like Haskell doesn't have everything, right? Neither does APL or BQN. Chi claims that Weewa has the most combinator support. It's got more of these than the other languages. But, and then this is the lambda calculus formula for the various combinators. So that's where the bird names comes from.
I just like that identity is a bird.
Well, actually, I think it was originally called the idiot bird. And I think idiot is actually the name of the bird. And I liked that name. I kind of like it because identity is kind of an idiot concept. It's just, I am me sort of thing. It just literally means, it's literally A is A. Right? And then kestrel, which is const. So in Haskell, it's id or ID. Would you call this id or ID? Id, right? ID? ID for identity. In const in Haskell.
ID, but maybe it should be id. I don't know.
But what I think is interesting about combinators in particular is that everything can be built from S and K. Now K is simple. K is just, right, given A and B, give me the left side, just give me A and ignore B. I think they call it const because the idea is that in mathematics, if you were going to say, have a constant value like 2x, the const would be the left value. So they're saying A and B, if B is the variable, A is the constant, just give me A, which is the constant.
I
Yes, that's
Right.
exactly it. You apply
That's
for
what
the
the term
function.
is.
You apply the first. I believe
Yeah.
first one is the constant, and
Yeah.
it returns you function that whatever you call it with, it returns you the thing you already put there.
Yeah, exactly. So that's where they get the name const, but of course they use K, which I guess is more of a Germanic way of saying const instead of C. I don't know. But the funny thing to me is that S is an interest is the Starling combinator, the S combinator, is a pretty fundamental one, which is you have two functions and you have one argument. You apply the argument to the first function, you take the result of that, and you combine it with the original argument for the second function. So your first function is monadic, it takes one argument, the second function is dyadic. And the whole expression takes one argument, that's the S combinator. It feels kind of exotic to me, it doesn't feel very straightforward, and yet somehow the simpler combinators can be built from the more exotic one, which is weird. But you can kind of go crazy and deep on that. I don't know if that answers your original question, but in Weewa, he's got the diagrams for what he says. So this is the letter, right? I, K, Ki, warbler, these are the names. Cardinal, bluebird. Bluebird is just straight up compose.
Like this is nice example of what I tried to say with words like 2 hours previously. That when you speak about a Starlink, it's so like hard to understand it, and
Yeah.
then you put there this very tiny, chart. And
It's
I'm like,
it's
oh, I see now. It just
Yeah.
goes left to right, but in the right way, it goes both before to G. I was like,
It's kind of fun though, the birds. I like using the bird names sometimes. What's funny to me is to think of bluebird as actually a combinator is almost pointless because it's just compose. It's just literally left to right or right to left compose. Right? It's the pipe operator. The pipe operator is bluebird. If you're talking about pipe and elixir or pipe and F sharp, it's literally just pass an argument to a function, the result to the next function, the result to the next function, to the result to the next. It's just a chain of calls of result to argument, result to argument, to result to argument. So it was funny to me that it was even given a name, but I guess in Haskell is it just the period, just the dot?
yeah. But there's the point that in pure, I believe in pure functional languages, the piping data and function composition is the same thing.
Yes.
But as soon as you have non-pure functional languages, piping data, such as in shell, and function composition, which is not in shell, but it could be, that would be two different stuff, because the things would happen when the data come, not when the function is composed.
Okay, I have to correct myself. I made a mistake, because I did declare this up with Steve, because I had a discussion with him before. There is a difference between the combinator and simply the pipelining, like you say in Unix, where you pipe the result to the next thing to be executed, right? The next process, literally, it's like result from process A comes input to process B. The combinator, the result of a combinator is a function, not the value. So when you're making a combinator, what you're doing is you're saying, give me a function that takes give me two functions that takes one argument. I'm going to give you back a single function that can take that argument, and I'm implicitly going to make the second call internally. So the result of a combinator is always a function. It's not, whereas you could imagine you're like playing a game of, pass the ball to the next guy. You're not giving the next guy a function. You're giving him the ball, then he gives it to the next guy, then he gives a different ball, then he gives a different ball, then he gives a different ball. So the combinator in this case is argument plus, or two functions, give me a function that I can pass an argument to. So really what you're ending up is a result of, you're giving it f and g, you're not actually giving it the argument. You're giving it the argument at the point of application. The combinator happens before the application. Does that make sense?
Yeah.
Okay. Yeah, that's how I understand it. But you're saying you don't like the bird names. Or
Did I say it?
You said something like, when somebody says the bird name, you can't see it. You have to see the...
No, that was about the exact. That doesn't matter. I think the bird names are better than the IKKI,
Oh, okay,
W and stuff.
okay,
So I
yeah,
think
yeah.
that the bird name is much better.
Yeah.
But still, like before when we saw the BQN notation, like the charts on the right are like definitely not implicit, you know. Like there's always only one combinator, so it's quite easy. But if you have two of them or three of them, it will be a chart, and the chart will have it will be a graph or chart. It will have like nodes and edges, and if you can see the chart, it's crazy stupid obvious what happens. It's just like the edges shows you the oriented edges shows you what happens. While if you have it the BQ notation or AP or J, not APL but dialog APL, you're like, well, like I have no idea. I just need to parse it hard.
Yeah, it's interesting that Haskell has some of its combinators or symbols. In some cases, they're words, right?
But since Haskell is pure functional, if you import I think it's called like the bird library, you have all of them. This point is just like the built-in ones.
Yeah, and actually, Connor has a library for C++ that has the combinators, but I think instead of the bird names, he uses the S names.
Yeah.
Because you're right.
For brevity. So I think it's prefixed with underscore or something. So he has underscore W, underscore K and stuff, and it's so unreadable, you know. Like
I actually ran into this when I was writing some code in Scheme because Adam makes the point, and he's right about that. If you have any language that's functional in which functions are first-class citizens, you can write all your own combinators.
Exactly.
You know, you might as well. But I was trying to see, there was one that I actually ended up, so I am doing my own language experiment. I am creating a language. And there is a particular construct that I use all the time that is not intrinsic to any language I've ever seen. And I use it all the time. And I don't understand why nobody has standardized this thing. And I actually implemented it in J for the bye bye hello world. There was an easy way to do it in J because of the way it supported the syntax and the semantics that it supports. But how many times do you have something, a value assigned to a variable, and then you say, if this is something, use that thing, otherwise use the original value without having to re-specify the value again? It's hard to describe. It would be easier to show.
I believe it's like all the maps in Haskell.
It's a tacit thing. If x equals 1, give me 3, otherwise give me x. I don't want to have to say x twice. I want to say give me 3 only if x equals 1, otherwise assume to use x. I want x to be just implicitly. And there's so many times you write code, you write if statements like that. If it's an exception, right? You're like, I'm going to use this value unless it's this value. I'm going to use this instead. Otherwise, use the original value.
But you're not redefining x.
You're re-expressing
so
it.
You don't like that the x is both in the like return part of the expression and in the condition.
I want one way to say, if this is not this value, use what it is, right? So it's like an exceptional case. And there's so many times I write code, I'm always restating the x. And also it feels like it's a potential landmine because you could make a mistake if you rename the variable. If you rename it in the comparison and you don't rename it in the other, it's one of those things where I guess it's in a terrible extreme, but it's not dry enough to me. I'm repeating myself when I feel like I shouldn't have to repeat this. I'm just saying, in this case, it's not this value, use this other value, otherwise use whatever it was.
Well, I think it's not standardized because if you have like, if A is bigger than B, then A plus 2, otherwise, should it return A or B?
So I came up with a term for it. I call it if instead. If x equals 3, instead 4. And that's it. I don't have to say x. I just say if this is true, instead. If x is this, instead this. I know it saves like one character or one type, but for some reason it was bothering me, particularly when I was trying to write tacit code. And I was able to figure out how to do it in J, but I couldn't do it in some other language. Oh, it was Lisp. I was writing it in Scheme. I'm like, And I thought, well, I can make a macro, or I can make a function. Like a lot of times in Scheme or Lisps in general, you don't even have to use macros. You can, most of the time, if it looks like a function, you can just write a function that serves the same purpose of a macro. The only advantage, I guess, of the macro would be avoiding the actual runtime function overhead, because the macro will be compiled out, right? It'll be.
So it like assumes that the condition is simple, that there is like one comparison
Yeah.
of one variable to some constant.
Yeah, it's not as flexible, but it's such a common recurring pattern, and that's the justification we make for anything that we try to.
So you can do it the other way around. That you say if constant equals something else, then you do the instance stuff, and the something else will be returned.
Yeah, I'm trying to remember how I did it in J, but J allowed a way to do it. Did you see the J video I did on Bye Bye Hello World? It's kind of crazy.
No, I haven't seen
I have 4 versions of it, and one of them is I'm now calling the golf version, but it's so unreadable. But it has no mutability, has no intermediate variables. It could be made even a little more tacit because it's got a few direct definitions in it. I'll just show it to you really quick because I've got the J stuff here. Let's see.
Yeah, I'm not sure how I caught wind of this, but I haven't seen your videos before.
Yeah, I'm trying to rope you into watching it, but
No worries. I just was trying to. Oh, right. You posted it to the Pronto's chat. That's how I saw it.
Oh, okay, great. Let's see. Let me find the Bye Bye Hello World. Well, let me actually just run the Bye Bye Hello World so you can see that. Where am
Justin, you work here, like in Pronto's.
I mean,
This is like co-working space, or how is it?
yeah, it's a co-working
So
space.
you like
I
often
have-
work here.
I have an office over in the other building,
Okay.
so I'm here most days.
I'm gonna close this out.
And Christopher, you are here like most of the days as well? Or?
No, I mostly work at home. I just moved to Obidush just this year.
Okay.
I came and visited this place a couple of years ago, and I met Kruli, and I was here for a month, and I worked out of here for the month. I was still living in the Algarve, but I decided to move up here. So I mostly work at home, but I like supporting Pronto's and working with Kruli, and sometimes it's nice to be in a building with other people and just working alone. I mostly work alone at home. But I wanted to show you this real quick. Where did it go? Oh, that's weird. It opened it over here. It's really strange. I don't know why it did that. That is really weird. I don't know why it's doing that. Hold on. It's just my thing just to edit files. Well, I'll show them to you separately. All right, so this is Bye Bye Hello World. God, I hate that it keeps opening it over in this window over here. All right, I guess it's because it's already open. Board. Where do we have this here? No, it's over here. Okay. Let me move the window over here so you can see it. This is really, I don't seem to have this problem at home. Okay. So this is J. This is Bye Bye Hello World. The program, let's just run it. So it just looks like this if you guys haven't seen. Can't even see what I'm typing here. So if you say run, countdown. You could get a countdown of like 3. Wow, what's it doing? Oh, okay.
No flashing.
It doesn't have the flush. Right, this was one of the shortcomings with J. So this is one of the things that was fun about this example is we would find gaps in various languages that wouldn't support what you needed to support. So if we were to do this in, let's go up to BQN. So here is a BQN. All right, that's what it's supposed to do. And if I put something at the command line, right? So it takes a command line argument, or it takes input. If I put something invalid, it says that's wrong, let's say a negative number. That's wrong, let's say a stranded array. Although in BQN I would have to put the little symbols in there. Doesn't like that. Let's put a really big number in there. Oh, that's interesting. So we were able to put in really big numbers in other languages. And like Erlang and Elixir, we could put a massive number and it would do it. You can see it's going to count that down. So that's just the program. That's what it does. And this is the J version. So this is a fairly readable J version. This is what I consider the default. I don't know how much you remember from J, but you can see there's some of the J syntax in there. It's a simple, single explicit definition or explicit function. There's a while loop in there. Right? Tries to get input, checks to see if it's a number. While it's not a number, it's going to continue to ask, and then it's going to output this. There's a sleep in here. You can see the U sleep. Right, so this is a fairly readable combination of readable and symbols. Okay, so we got that now. Actually, let me switch this over. Source room. So people can see what we're talking about here. There it is. Explicit J. Okay. So there are 4 variations in here. Let me close all this. I got too much stuff open here. Let's go here. EBHW. You can see all the languages we plan on doing. Quite a few there. All right. Here is what I'm calling a very wordy version. So in J, some of the symbols are actually, they have keyword aliases for them, so they're more readable. So if we look at let's close some of these other things out here. That's the inline version. It's BQN. All right. So this is using keywords only where there's no other option, like there is no symbol for whilst. You have to use a keyword. There is no thing for sleep. You have to use a keyword. But some of the output ones, TM output, SM output, you can see the if statements instead of using question marks and things like that. So this is pretty readable, right? There's hardly any symbols in there. Pretty straightforward. And then there's one, so the opposite extreme of this is the golf version. This is the golf version.
It definitely would be a commitment to unreadability to make. Sleep,
Well, I think
to make sleep have a symbol. That would be.
Yeah.
I'm glad to see they didn't go that far.
Right. So this the only ones we see in here are argv for the
It
input
would be
argument.
the easiest symbol if it would be like ZZZ. You know, like big Z,
That would be-
smaller
yeah,
Z, and
that would be
smaller
good.
Z.
That
It
would
would
be
be
good.
so nice, simple symbol.
But you can see this isn't even tacit because we've got direct definitions or lambdas in here. We have named parameters.
So you
So-
can go much further. Like
I can make it. I can make it more. I can.
Don't
If I spent time, yeah. I mean, this is not a successful golf version because there's got to be a golf version that's even shorter than this.
Presumably, it's entirely possible that those strings could get replaced with some kind of expression that evaluates to the string.
That's true.
Yeah.
That's true. Yeah, it would be a challenge. But
Not guaranteed, but it's possible.
But I think any good J programmer look at this go, you're crazy to write it like this, which is why I picked the this is a more reasonable thing. Oh, we got protests going on. Cool. But these things, these foreigns, these are the inputs and outputs. Steve hated these. He's like, this is just nuts. Anytime you do I/O, it's these numbered things. They're called foreigns. But if we look at the APL version, so let's look at the APL version that Adam wrote a one-liner of this in APL in dialogue. Here it is right here. So he said, he would recommend somebody writing it this way. But if you were going to do a golfy one-liner version, that's what you'd end up with. And it parses from right to left. Now it's not fully tacit because he does have arguments in here. There's omega, right? So these are defins in here, lambdas. So just like the J version, there might be a way with combinators to compress that stuff out.
Well,
But it does execute all on a single line. And it does work, it does the full spec of the program. And there is the sleep in here. It's actually not even named sleep. I think it's,
Well, I think the point is not that it's on one line.
oh, it's right there.
With semicolons, you can write everything on one line, but it's like single expression, right? Or no, it's not.
It is a single expression. Yeah.
Because that's the point, right? You see, you can write the whole thing on one line every time. You just put the semicolons.
No, you're right. It's not. Well, actually, no. It's not a single expression.
It's not a single expression.
Because the diamond is in here. That's the diamond. The diamond is the state separator to APL.
So
you're right. It's
like
not a
right
single
now,
expression. Yeah.
to not put here a new line is like why? You know what you gain by this?
Yeah. And he did a version like that where it wasn't. Well, this is where he says inline. He does one. I think this is the one. This is the one where you're right. Those same functions are essentially separated, except he does name it. He does name. So you can see this is the program. Greet, get count, and then do the thing. Right? But you were saying this thing about sleep. Actually, in Dialog APL, it's quad D for delay. So it is a single letter.
well,
But then UCS over here for, UCS.
that's I'm gonna call that dubious.
Yeah.
Actually, no, I'm sorry, I'm wrong. This is digit,
Yes.
delay is DL. This is delay. I wasn't reading it properly.
Well, you picked up a different place. It's the same principle.
Yeah.
I think it should be ZZZ. Like
ZZZ,
sleeping.
yeah. And they would, they'd said, well, the quad functions aren't really the core language, right? They're the peripheral thing. And in BQN, instead of using quad, he uses a big circle and named functions. All the system functions have names, they're not symbols.
That's sort of that's my thought. Is it's not a core thing, so it doesn't merit a symbol. You would think.
No, you're exactly right.
There's a logic to making combinatorial symbols, right? You expect that you're going to use the combinatorial constantly, or at least some of them. Right? There's an idea that programming languages are each optimized in terms of their syntax to make certain things easy, right?
Yeah.
And an array language makes mapping over arrays easy. A combinatorial language makes combinatorials easy. Haskell makes higher order functions and function composition easy. C makes manipulating pointers easy, or at least syntactically quick.
Yeah, it does. Their lambda, their closure syntax is the worst though. In C++ 11, to do closures, they literally use all three of the boundary symbols in a closure definition. So you've got square brackets, round parentheses, and curly braces all within a single expression. It's so complex the way they made it. The point I wanted to make about BQN is you can see the system functions all have names, and you can see them in that the yellowish color. So where's my? I hard time seeing that. They have this dot. So that's BQN instead of the quad. It uses the dot. And if you go into the language definition, it says these are the system functions. So this is the boundary, right? This is the imperative shell, where you've got I/O. There's delay, flush, get line, out.
That's an interesting use of syntax highlighting. Is that a theme you did, or is that built into the language? Or
It's a Vim color scheme. I just picked different color schemes for different syntaxes. But it is parsing the syntax. And actually, he does have a little help thing for BQN. You can say help BQN, and you do get.
You need to install some plugin, or this is like.
It's Vim. It's just Vim.
It's in Vim by default.
No, it's an add-on. It's a Vim add-on. I don't use the plugins. I just copy the Vim syntax files over and stuff.
Oh, yeah.
Yeah, and then if you don't have the keys memorized, you can see he's got the symbols in there. He actually shows you which keys on the keyboard you can use to do it. So it's a little easier to use. But this version, I'm working on a rewrite for this because this one has mutability, has mutation. These intermediate variables get mutated in here. So I already wrote, and I did the same thing in Scheme. It looked a lot like this. And I'm like, this is bad. I need to make it immutable. And I want to get rid of these intermediate. This drives me crazy. Look at how many times count shows up. Look at how many times input shows up. That I don't like. That bothers me a lot. And it's almost written in a structured style. This while is a special. This is a special while that's tail recursive. Because the problem is if you use the symbolic version of control flow for tail recursive, it's not tail recursive. And for something that's infinitely getting input, you have to be tail recursive for it to not blow up on you. But and there's not a heavy use of any array stuff in here anywhere. It's like literally X is an element of that. Just make sure it's a digit.
So what you just said, I don't mind like repeating stuff. The input is there like 5 times. When
1, 2, 3, 4, 5, 6, 7, 8 times.
The point is, once the thing is constant, it's usually much more readable. When the thing is used or like more like read many times compared to having some crazy combinatorics to have it only as one input and then some complicated function will transform it in so many ways. But I don't like when you mutate it so many times because
No, I agree with you. Mutation is the main problem. There's no excuse for having it mutable in a functional language. There's just, yeah. And in fact, when I did a Scheme video, it was one of the recent ones I did on Bye Bye Hello World, and some Scheme guys commented on it. They said, yeah, you're using mutation, but since Scheme allows it, I'm like, yeah, but it's not. One of the main selling points of a functional approach is to be programming immutably, in my opinion. Really, really important. So. Well, we've actually run over.
Nice.
So,
it's time to say bye-bye.
yeah, well, this is our first meetup. So you live in Lisboa?
I made a visit, yeah.
Oh, okay.
Like I wanted to visit Lisbon for some time, and this was a good excuse. So I had no way here from Prague. It was just purely like this happens, on Saturday. So I said to my girlfriend, "Hey, don't you want to visit Lisbon?" And she was like, "Yeah." I was like, "Okay, so what about this weekend?" And she was like, "Yes."
Nice. That's great. That's amazing. You made the trip out here.
Like a big motivation was when the guys at Ericast said it. They were like, yeah, it's in Portugal, so it's like pretty convenient from basically any Europe. And I was like, yeah, in the in the States mindset, that's true. The people often like go visit someone like across 2 or 3 states.
Yeah.
When you live in Czech Republic, you are not so used to visit someone across 3 states like often, or like go to a meetup from Czech Republic to Lisbon. It's not like so common, but it's actually okay, like
Yeah.
it works.
I have a really good friend who's from the Czech Republic. He lives in the U.S. now, but I haven't made it to your country yet. I definitely want to get over there and check it out. Yeah, so that's amazing that you came down for this. Well, I hope it was,
It was a pleasure.
Get some good stuff out of it. Yeah, it's great. But hopefully we'll be doing more meetups, and not just about array programming, but anything in programming languages. I decided this is the big project I'm going to be doing is this, this website and understanding and explaining and having a factual source of information across the board for all languages, including the ones I don't like. JavaScript. C++. Ones I spend too much time in. So, and I'm sure my list of favorites will change. Connor's are practically changing every week. Every time he gets on a cast, he's like, my new favorite language is now this. So, and then Justin, you're around. You live in college?
I live here in town. Yeah.
That's great.
Just like 3 or 4 minutes walk from here.
Nice.
It's a great area.
Yep.
Yeah, I pretty much decided this is going to be home from here on out. The Algarve was not for me. I was there for 3 years. But I really like this area. It's really, really nice. And good weather, too. What happened to the protest? It just
I
came
think
away.
it walked away. I don't think it started here. I think it was in March.
You ended the streak already, or
What's that?
did you?
Oh, it's still going.
Uh,
I don't know if anybody's watching it. I'll make an edited version of the video and then put it on Proglandcast. Steve's already got the Elixir one ready, so I need to publish that. We need to get doing stuff more each week. Is anybody still out there? Oh, wait.
Got questions?
Happy to be a fly on the wall of this discussion. Like many, I'm the odd bird in my organization because I'm interested in this stuff. I happen to be reading the proceedings from the workshop today on physics and computing from 1994. Combinatory logic comes up quite a bit. Oh, really? That's interesting. Is he still there? I don't know if he's still watching. Let me see. It's not telling me how many people. Oh, this is on OBS. That's why I'm not seeing it. Let's see. Are you still out there? Actually, let me look at the other one. Tell me if anybody's still watching. So somebody, concurrent viewers.
like I'm watching right now, and it says there are 3 viewers. So if you watch as well,
So it's probably you, right?
there will be like 1 more people, like 1 more person.
Yeah, if there's just 2, I think it's
because
you
it
and
says
you.
like 3, and I'm 1. You're 2nd. So
Yeah, mine says 2.
well, I shut down. I shut myself down. So
Depends on how fast YouTube's actually updating that in real time.
I'm better certain than Rust. So it will be pretty fast.
Still says 3 concurrent viewers.
Well,
Let's
To
see
get
if
that
he's out
one,
there.
it's all about.
Oh, yeah, he's still there.
How it's handling the network.
Michael. Oh, there's somebody else in there. Elias. Michael Elias.
hey guys.
Well, say hello from us. Let's see. Where are you all? Santa Cruz.
Wow.
I know Santa Cruz pretty well. Yeah. It's a pretty great place. Good windsurfing. Waddell and Davenport. Lots of great white sharks, though. They call it the Warden at Waddell, the great whites that are out there. So he said he was reading the proceedings from the workshop today on physics. Oh, he works at the university. Oh, UC Santa Cruz. Yeah, that's cool. Combinatory logic comes up quite a bit from 1994. Yeah, I like Tacit. I like combinators. I'm definitely, the language that I'm throwing together, I'm trying to put support into them. Just randomly saw the stream, my recommendations, probably because I was doing the interview with Connor yesterday. Oh, Elias.
Interview with Connor. Can you
Are
tell
you the
more
crea-
about it?
You're the creator of CAP?
Ah. Wow.
I didn't get a chance to cover CAP, but I did watch the I did watch Tacit Talk yesterday, which was great. Interview with Connor yesterday, yeah. Yes, okay, so Elias created CAP. Yeah, it's good. I came in late to the stream, but the full thing is recorded there. And yeah, so more array languages are good, or at least more array programming. So I'm nowhere near along where any of these folks are, so I'm just getting my feet wet and starting a little language. But I was basing it originally on Scheme because I liked Scheme, but I've now decided it has to have array support within it. I mean, why not, right? And I may steal a lot of the BQN implementation because it's small, it's lightweight, it's fast. So definitely inspired by that. And CAP is in Kotlin. Yeah, well, cool. I don't know how much of it you saw that we were discussing here, but I think we're at the end of the run. And I'll yeah, like I said, I'll put an edited version of this in here. I don't know why I still have the crazy J version of the code up there. Yeah, that's pretty unreadable. Well, any other final thoughts? Yeah, okay. Well, we're glad to have you the last 10 minutes. I don't know how much of it will be of value. You're way ahead of us on all this stuff, so at least I'm speaking for myself. This is a learning process for me, but something I definitely plan on pursuing. I know that whatever programming I do, I definitely want to have array language support and stuff that I'm going to be doing. And I like symbols. I prefer them. And Tacit for sure. So. And you're in Singapore. He's in Singapore. So what time is it there? It's got to be almost 12 hours opposite of us, right?
No, I think not.
No, that's right, because I keep thinking in terms of the U.S., because it's like a 17-hour flight from California to get out there, 15 hours or something like
I
that.
guess something like 8 or something.
Yeah, we're closer to the east side. I got to get used to that. I've been living over here for, wow, this is my 5th year in Portugal. Wow, time flies. I knew the other time, but I have no desire to ever go back.
And you're from the States, or?
California, yeah. That's why I know Santa Cruz. Oh, it's midnight. A little after midnight, 0023. So, yeah. So how long have you been in Portugal?
Since January 2023.
Okay. Is this your new home? Is this your new home?
Probably.
Yeah.
It's, it's a year and a half, right? So,
And where are you from previously?
North Carolina in the U.S. What part of Czechia are you from?
No, but Czechia is so small that I'm just from the middle, It's like, I live in Prague for 6 years, so I consider myself from Prague, but
I'm gonna get out there at some point. I definitely want to see more of Northern and Eastern Europe. I haven't been there yet. Still exploring areas of Portugal I don't know yet. I haven't been to Braga or Jerez or most of the south I'm pretty familiar with now.
how did you pick, both of you, Portugal?
Well, for me, I started becoming a digital nomad probably around 2014, and I just started traveling around the world and working from wherever, and knew I wanted to be out of the U.S. So I made a spreadsheet of countries. I ranked them based on my values, and Portugal floated to the top. Second choice was almost Uruguay, South America.
Okay.
Before that was New Zealand.
Can you share the spreadsheet?
Sure.
No, because it's interesting, you know, I'm like ranking the countries as well, but Portugal never stood up in any way.
Well, you and I might have different values.
Yeah, that would be interesting about, like, I don't care about the order at all, but the values would be interesting. Like,
Okay, so I'll tell you some of the things I ranked on, even though some of them are semi-political. Here are the things I like about Portugal, why it's up really high. There's no oil economy, right? So the main export here is paper and cork. So there's no real business in oil. I mean, they have an oil company. There's no nuclear power. There's no nuclear weapons. They don't have a massive military budget. It's actually close to being a true social democracy. They actually have public health care. They take care of their people. They have a high tax rate, but the tax goes to better things than bombs to destroy the world. So I like that. It's fairly warm. I mean, it's reasonably warm. Like, there are more social democratic countries in the north, like Denmark and stuff like that, but it's just too cold for me. I don't like the cold that much. I like the language a lot. It's very affordable. The only places I've lived that have been cheaper so far have been Mexico and Croatia. And I knew I was going to be in Europe because I don't like to fly. And the problem with being in somewhere like New Zealand or South America, the only way you're getting around anywhere is flying. They still have some trains in South America. They have none in Mexico. They got rid of all, Central America and Mexico, the oil industry destroyed all the trains, so there are no trains left at all. So you either have to fly or take a bus. The buses in Mexico are pretty good though. They have pretty good buses. But I prefer to travel by train. So if I were to go to, like, for example, when I go to Croatia and stuff, I go by train, take the trains. I don't like to fly.
I do the Amtrak, you know, and
I do the Amtrak in the U.S.
yeah.
Yeah.
And it's when I saw the map, you know, like the trains in the U.S., I was like, oh, is this like all the trains you have there?
It doesn't get much love. Trains don't get much love. But the Pacific, the one that runs from San Francisco to Southern California, actually it goes all the way from Seattle. I think it goes to Vancouver. It goes all the way down to San Diego. That's actually a really beautiful
I
train.
took that one actually.
It's a really nice one.
My 3-year-old son opened the back door of the train.
Oh, did he?
Yes, you
Wow.
could hypothetically have walked off the end of the train. I
Yeah.
don't know if that was supposed to be openable, but that was fun.
So yeah, and I did take the Amtrak once. I was trying to take the shortest flight to Portugal possible, and the closest spot from the closest flight is actually to Brazil, but the closest flight to North America is Montreal. So I was trying to get trains all the way to Montreal to take the 6-hour flight from Montreal to Lisboa, so the 12-hour flight from California. So I spent 3 days on trains. But the train broke down. I got stuck in Chicago. So then I had to fly from Chicago to Miami and then take the plane to Miami. But I spent 3 days on the train there. I like traveling slow. I like trains. So what else about Portugal? I could become a citizen in 6 years. France is 10. Spain is 10. Ireland is 5. You can get a citizenship in 5 years in Ireland.
What's the requirement to, if you live here for 6 years, you become citizen?
No, you have to pass a language test.
Yeah, but still you can just like, how is it called?
Apply.
Like apply for the language test.
Yeah, to my understanding, yeah. Yeah, this is my 5th year, so at the end of my 5th year, I become a permanent resident, right? So I'm a temporary resident. You're a temporary resident? Yeah. So it takes 5 years to get your permanent residence, and you have the option to do that. You can stay as long as you want, but you're not a citizen. Or if you want to become a citizen, pass the language test. So I've got a lot of work to do to get the language test done. But 6 years for Portugal, 10 for France, 10 for Spain. Like, another place I would like to live is the Canary Islands. But again, you want to go anywhere, you're going to be flying. But it's a mecca of windsurfing. I'm a windsurfer, so. and the weather there is amazing. It's like 70 degrees all year long, the whole place. Spain, politically, not as, I like Portugal more as a country than Spain, although I think they've done some nice things lately. And I learned Spanish before I started studying Portuguese, but it's Mexican Spanish, which is a little different. I didn't really get fluent, but I mean, I could get by, have conversations. I lived in Mexico for about 6 months, lived in Panama for a while, was in Colombia for a while. So anyway, my story's too long. What's your reasons?
Pretty simple. I mean, we wanted to move. We wanted to shake things up, and Portugal worked and has good weather. It's got the culture's, I feel like, welcoming towards kids. Like, I mean, you know,
It's a family-oriented culture,
family-oriented,
definitely. Yeah.
Not like super strict, and then financially and like residence-wise, we could make it work out. We could get a visa and be able to move.
I call Portugal mid-tech. It's not low-tech, it's not high-tech, it's kind of mid-tech. And that's my speed. Things kind of move a little slower here. I like that. I like the speed. It's laid back and it is family oriented. It's a very communal place. You know, I had to learn that, discover that before. I mean, on the spreadsheet, I didn't know that before I came here. So I like it. The ecology and the weather is identical to California. It's the same. It's literally the same. It has a western coastline. It's a chaparral biome. It's the same biome. The weather patterns. This place is Lisboa is almost identical to San Francisco Bay Area.
So where is the Silicon Valley?
What do you mean? Oh, in Lisboa?
Yeah. No, Lisbon. Like, if Portugal is like close to California.
Oh well, I don't like the Silicon Valley anyway, so I'm glad they don't have one here.
Yeah. So it's missing and it's good.
That's good. Yeah, we don't want Silicon Valley. Yeah, I'm not into that culture. I like San Francisco as a city. Like San Francisco itself is very cool. I grew up mostly in Southern California. I grew up at the beach. So, but I wasn't looking at something that was like California. That wasn't a priority for me. It was more the other factors as well. If I had to leave Portugal, where do you think you would choose?
I don't know. That's very boring. I don't know.
Croatia is really nice, and it's actually cheaper. It's a little cheaper. They speak even more English there, so it's easy to. The one thing I don't like about being in Portugal is how much English is accommodated, because it doesn't force me to learn the language. Like if you go to Spain, they don't accommodate English as well in Spain. You go into a store or something, start speaking English, they may not even like just teach you Spanish, but Portugal totally accommodates English. And Croatia even more so, because nobody speaks Hrvatski. Nobody speaks that unless you're from Bosnia or Croatia and stuff. In fact, I tried to get by a little bit with please and thank you and stuff and try the language, and they're not having it for the most part, I think. Right? But it's a coastal country. All the towns are on the coast. The water. Have you been to Croatia?
Yeah, like being Czech, almost for sure you visit Croatia as a holiday place.
For a holiday, yeah,
because
it's beautiful.
You said it's cheaper than Portugal, but it's also like probably what you get for what you pay in Croatia is very like good ratio. So a lot of Czech people go there for like 1 week, 2 week holiday, maybe some people go like 3 week holiday.
And it's only a couple hours to get
Yeah,
there.
I think that it takes like, I don't know, 9-hour drive,
Yeah.
something like this.
That's like going from one end of Portugal to the other, or even not even that full distance. The water is so clean there. It's so beautiful. You can see right through it. It's funny, I was there and I said, your water is so clean. Like, oh, you should have seen it years ago. It was so much better. I'm like, dude, just go to California. You have no idea. People have this image of California, this mythology, beautiful beaches. There are no beautiful beaches in California. everything is polluted. The beaches are covered in trash. The water is garbage. There's one thing I love about the coastlines here. The one thing I never see, you might know this too. You were from North Carolina, right? Outer Banks.
Yeah.
We've done a lot of windsurfing and teaching windsurfing in the Outer Banks out
Okay.
there. I don't remember the Outer Banks, but I can tell you there's not 1 inch of California coastline where you will not see an offshore platform. It's going to be in your view, no matter where you are. There's going to be an oil platform off there. And that crap is in the water. I could show you old surfboards I have that have tar on them that come off of that. And there's constantly oil spills. So people think it's beautiful. It's not. The water's polluted. The air is polluted. I lived in Long Beach and I was teaching windsurfing across from these oil islands that are right there off the coast. And they put these kind of decorations to hide the oil rigs so you don't see it. But you're breathing the air constantly. And you're just smelling gas. Just all day. It's completely polluted. So when I went to Croatia, I'm like, oh my God, I can't believe how clean this place is. But I know the reason. There's no heavy industry. There's no industrial farms, right? I don't see them, at least not on the coast. They're not running stuff into the rivers and out into the seas. Any coastline you go to in California, within a few miles there's an oil refinery on the coastline. Not to mention a couple of nuclear plants, right? Diablo Canyon. Yeah, it's toxic. It's a very toxic place. And I like non-toxic stuff. I'm being very political here, but yeah. So I don't know. I thought the water of Croatia was amazing.
I should probably go.
Yeah,
It's
man.
nice to meet you too.
Thanks for coming in. Appreciate it.
Yeah.
Hope it was worthwhile.
Nice to meet you.
Nice to meet you.
Matt.
I'll see you around.
Yeah.
Very likely. I'll try to spend more days in Prontish, hang out with people.
The cat follow it.
Oh, it's okay. I'll take it.
You saw it?
Yeah,
It's right here.
it's on the floor.
Oh, thanks.
No problem.
Well, I'm going to call that a success. First meetup for the Portugal programming languages.
Actually, I